Well, this is the STS-88 crew video, the first assembly flight of the International Space Station. And our flight really started back in November of '98 with the launching of Zarya, the first Russian-built module, paid for under contract to Boeing, launched aboard a Proton rocket from Baikonur in Kazakhstan.
Get onto orbit, and the first thing we have to do is to open up the payload bay doors so that we can start cooling all of the electronics inside the orbiter. The doors are actually opening at a faster speed here, shown at a faster speed than what we actually open them at. It also gave us our first really nice view of Unity in the back of the payload bay.
On the second day of the flight, we went ahead and checked out the shuttle's robotic arm to make sure it was operating fully, and the shuttle's robotic arm worked just great. It flew identically to the way that our simulators fly. These are the snares closing. That's the manner in which we grappled Zarya, was through closing those snares onto the grapple fixture that was mounted to Zarya. And then on flight day 3, it was time to extract Unity from the payload bay. It was wedged in there pretty good. We had fairly limited clearance to bring it out of the bay, so the whole operation took about an hour and a half to maneuver it up and then onto the orbiter docking system that you saw on the forward portion of the payload bay. And we just flew the arm very slowly, and Jim was great help being my assistant and letting me know how quickly we were moving the payload. We then pitched it up about 90 degrees, rotated it around to align it properly with the orbiter docking system. And the unique thing about mating these components is we actually didn't use the arm to bring it all the way down onto the orbiter docking system. We took it so it was 6 inches apart, and then we fired the thrusters on board the shuttle to provide the closure rate necessary to attain the capture sequence. And you saw the thrusters firing there.
Nancy did an outstanding job pulling the payload out of the payload bay Unity. Couldn't have done it better. Very smooth and controlled and precise. She had less than an inch of clearance on either side as she brought it up. She was pretty happy when everything turned out right. And here you see the final closure of the Zarya with the orbiter docking station, just like we dock with Mir Space Station. Once pulled together, we have a solid mating surface. We drive the hooks and can pressurize it so we can go inside.
We had a lot of EVA equipment that was stowed in the middeck of the orbiter, and every time we had spare time, we would go down and start to prepare that equipment for going outside on our 3 spacewalks.
The rendezvous was absolutely fantastic to see Zarya, which means sunrise in Russian, out on the horizon as we closed in on it for our capture. What a beautiful sight. Rendezvous is a real team effort. You can see us working on the flight deck here as we approach Zarya from 600 feet underneath it. Everybody's taking pictures. There's Jim using the handheld laser to get an accurate distance from it along with our other tools. Rick has moved up into the commander's seat, and I'm moving back to the aft flight deck to fly Endeavour as we come up to 600 feet and then move 350 feet out in front of Zarya, and then come up 250 feet above it and fly it right down in the payload bay. We were using cameras for positioning. Here you can see it approaching its movement down in the payload bay, actually disappearing behind the node as it gets in closer. And here's a computer view of our profile as we flew it in.
We use the laptop computers to help us better understand orbital mechanics, because it's not always intuitive.
The final grapple and proximity operations were done at night. You could see it starting to get darker there, but the orbiter payload bays and the cameras we have allow us to light it up so that we can see it well. We ended up bringing it down in the payload bay and then station keeping on it for what Nancy and I call the longest 17 minutes of our life, having Zarya about 2.5 to 3 feet from the end effector and keeping it still there.
This is a view from the end of the robotic arm and the camera located on it, and this view is now actually from the Russian module Zarya looking down on the arm as it comes into grapple. We actually didn't have that view in the cockpit. And So it was quite a unique experience to know that the ground was looking over our shoulder literally as we came in for the grapple. So we brought it down right over that grapple fixture, that long pin, and closed the snares that you saw in the earlier version to attain the grapple and rigidization process required to maneuver Zarya around. We were very, very happy after we grappled this 45,000-pound free flyer after Bob had literally flown formation with it at Mach 25. And then it was time to install Zarya on top of Unity. Again, we were operating almost at the limit of the robotic arm because the Unity module extended about 40 feet out of the payload bay, and so the arm was almost fully extended as we brought Zarya up and over Unity into the install position. We actually couldn't see the mating surface where it was going to mate, so we had to use cameras alone. This is the elbow camera view. And again, we fired the thrusters to attain that capture sequence with the androgynous positioning mechanism.
Just a really nice view of the space station docked to Endeavour out the overhead window. Now it's time to go to work and start the spacewalks.
Here you see Rick and Sergey as they're opening up the hatch that goes from the middeck or living volume of the space shuttle back into a tunnel that leads to the airlock where our spacesuits were stowed and what we use to go in and out of the space shuttle on our 3 spacewalks. Here we are in the middeck, Jim on the right and myself on the left, as we're demonstrating in space that you can put both your legs into your pants at the same time in zero gravity. After I got my pants on, I went into the airlock to start getting into the rest of the suit, and here's Jim finishing his suit up and going back through the tunnel to the airlock to get into the upper half of his spacesuit. You might notice there's a lot of tools and equipment stowed in that tunnel. There were more that were put in there after we got into our suits, and we used that volume very much to our advantage to transfer a lot of equipment outside to be added to the external surfaces of the station. Jim now into the upper half of his suit, he's putting on his Snoopy cap, his comm cap. We had to put on our gloves, button up our waist bearing, and put our helmets on, and then go through a check out of the suits and a pre-breathe to make sure that we didn't have any problems with the bends. And then when that was all completed, it was time to go outside and start our task.
Here's the cracking of the egg as Jerry opens up the thermal cover and begins the first spacewalk.
We went right to work. We had one crew member that was normally working on the end of the arm and a foot restraint that we had attached there. And the other crew member normally did most of his work in a free float manner, holding on to the sides of the orbiter and space station as he did his work. Nancy operated the mechanical arm for the first 2 spacewalks, and Bob operated on the third one. The arm gives us a very good work platform. It gives us opportunity to have our feet anchored in a foot restraint, and therefore leaves both of our hands free to do the types of assembly work that we were doing. The most important part of the first spacewalk was the connection of 40 different electrical connectors that allowed all the communications and control signals to be transferred between the various different elements of the station, and also, importantly, the electrical power to be transferred from Zarya down to the Unity module so that we could start to activate all the systems inside the US-built Unity module.
Here you can see the power tool that we used to loosen a lot of the bolts that were holding down the cables for launch.
Jim normally was responsible for removing those cables, both the bolts and clamps that held the cables in place, and then he would hand those off to me, and I would make most of the electrical connectors. He also made some of them. And you can see we're working at the orbiter end of the node there, finishing up the electrical connectors there. We then strung a slide wire, which was something that allowed us to transport ourselves up and down the side of the node very efficiently. Then we went to work at the top of the node to remove the cables at that end from their launch positions and to connect those for their on-orbit use. You can see Jim here translating up the side of the node using the slide wire that we had just installed, and you can see he's carrying a foot restraint with him that he used for some of the tasks up at the other end of the station.
This shows how useful the body restraint tether is. It's a way of carrying equipment around or of attaching myself to a handrail so that I can have a more stable area to work and can free up my hands to work if I need to.
Here I am again up at the top end of the node, finishing up the connections of the electrical connectors from the PMA, and here are Jim and I now up removing the cables from the Russian-built hardware, Zarya, and transferring them across to the PMA-1 U.S. hardware and allowing electrical power to flow into the U.S. half of the station. Since we were ahead of our timeline, we continued on with tasks that were planned for our next spacewalk, and here we are transferring some equipment so that we can each go or do our own task. We were installing some handrails and some additional foot restraint sockets that were used on subsequent spacewalks.
After the completion of the first spacewalk, we then activated the space station from inside and actually turned on the computers and electrical power to it, and what a great moment that was. After that, we boosted the space station to a higher altitude using the +X RCS jets on the orbiter. Each one of those jets gives about 800 pounds of thrust, and through a firing sequence that required a lot of analysis so we didn't break the space station. You can see it oscillating back and forth here after one of the firings. We boosted it approximately 8 nautical miles with 11 firings. A little oscillation in one of the solar arrays there. It was 2 minutes and 10 seconds between firings, and that all damped out before we did the next one.
Okay, on the second spacewalk, it was my turn to go outside first to get on the arm, and our primary task on that day was the early communication system. What we were doing is bringing up a communication system that would allow Houston to have video teleconferencing and command and data to the fledgling space station. Although the Russian side is prime for communications early on, they are restricted to communications during their ground passes, and that leaves a lot of the orbit with no communications to the station. And here we are transferring some of that equipment, those antennas, using the arm and the body restraint tether. You can see here that with an orbit that goes around the Earth every hour and a half, that there's 45 minutes a day, 45 minutes of dark, and during the dark times we keep working using our helmet lights. Here we are up at the Zarya Unity interface, and from there I transferred with a boat hook. There are antennas that the Russians had expected to have deployed, but which did not employ, one on each side. So Jerry and I each on 2 different spacewalks took this boat hook and encouraged the antennas to deploy. It turns out they just needed a little nudge, and after doing that, and allowing a little bit of time, perhaps in this case, to warm up. And don't blink here, because what we'll have in a moment will show you what the antenna itself looks like, and then we'll show a picture of the deployment itself. The antenna is a coiled metal on a spool, and there goes the spool. So with activating and deploying that antenna, now the Russian Toru system, which is a manual backup to their docking capability, would be fully operational.
Jim turned real quick there and said, "Where'd it go?"
I did blink and missed it, and I made a quick turn to try to see where it went. On the next one, which Jerry will tell you about on the last EVA, I didn't blink. This was a shot of the end of that final spacewalk as we were cleaning up the payload bay.
At this point of the flight, we had a space station that was ready to go inside, and we began our first day of docked operations with actual ingress into the space station. And what a highlight of the mission to see everybody's hard work come to fruition. Been a long time coming, but to go inside the space station for the first time was really exciting. Here we are opening the hatch, going from the orbiter docking station on into the pressurized mating adapter 2, kind of like the front porch of the space station here, and then opening the main hatch into Unity. And Zarya means sunrise in Russian, and of course Unity is binding us all together. It's the connecting piece which holds all the other modules from the space station. It was a very bright, roomy, and nice place to be. It was quite a sequence to go through all the checks that we had to before making sure it was safe that we could open the hatch, making sure the pressure was correct on both sides. After progressing on, we went through PMA-1 into the first compartment of the FGB of Zarya, and then opening the hatch into the main compartment of Zarya. The purpose of the FGB is to provide the initial electrical power and flight control for the early stages of the space station. Here we are all inside Zarya for the very first conference from the space station. Sergei Krikalev, our Russian crew member, will actually be going up to live on the space station with Bill Shepard and Yuri Gudzinko, and he's checking out his new home here, future home. Sergei has over a year's spaceflight experience on the Mir space station, and as you can see, he readily adapted to microgravity and being home on this module. Watch how effortlessly he translates down to the other end. Very nice place to be, more of a corridor than anything else, not meant for living. Here we are with the early communication system. Jim and Jerry installed the antennas on the outside, and then Jerry and I installed the boxes inside.
The Zarya had 6 batteries, one of which was not operating fully after the launch, which was 2 weeks prior to the launch of Endeavour, and so they had the opportunity to send over a replacement unit that Sergei and I removed and replaced, and an hour later it was up and functioning. So we felt very good about that, and it's another testament to having human beings in space to fix things and get things operating again. We also had to remove a lot of structural panels and bolts that were put in specifically so that the modules could withstand the loads at launch. And we wanted to remove those to make accessibility behind the panels easier. So we ended up bringing back about 800 bolts and nuts and washers back from the space station.
We had to pinch ourselves every time we looked out the overhead window. It was just hard to believe that we were docked to a new International Space Station. The view of the aft and forward flight decks of Endeavour. Kind of take you on a little tour as we transit through the mid-deck access hatch. Behind that door and curtain is the bathroom on the space shuttle. The mid-deck is where we do all our living and sleeping and eating. Here you can see Jim down on the mid-deck. He was in charge of transferring all the equipment to and from the space station, making sure that what went that was supposed to got there and what didn't stayed. Rick's bringing back some stuff that had been removed from the space station for shipment home to Houston. These large bags held all that equipment. You can see it was kind of a tight squeeze. We had a lot of stuff packaged all over. Again, transiting through the hatch into the tunnel that connects to the airlock. You can see a booster fan down there to help circulate air between all the modules so that we could scrub the CO2 and provide oxygen for everybody, as well as maintaining the proper temperature and humidity. Instead of going out through the aft hatch, we now go up through the upper hatch of the airlock into the space station. More of that ducting circulating the air. Into the pressurized mating adapter, and then down into Unity. Here's Jerry and Nancy reviewing procedures for the next work that they have to get started on. We were really busy for the 2 days that we were docked to the space station. Across Unity into pressurized mating adapter 1, and here comes Sergei floating by as he exits Zarya. Into the first compartment of Zarya. Again, you can see the ducting that we installed. And finally into the main compartment. Again, Zarya is not meant to be a living module. It's a working module and more or less a corridor between the other modules of the space station. A really fantastic facility. Probably one of the sad points of the mission was when we closed the hatch on the space station after being aboard for 2 days. It was really, we wanted to stay longer. It was a great place to be.
Here we are checking out one of the simplified aid for EVA rescue, a little jet backpack before the third EVA.
One of the primary tasks of this spacewalk was to add a very large bag, about 3 feet on a side, to the outside of the station, which contains a lot of tools which will be used by future crews in the assembly processes of the station. After that was done, then Jim and I came back down to the orbiter end of the space station and disconnected 6 cables and stowed them. Those cables are no longer needed, and to get ahead for future assembly tasks, we removed those cables and stowed them.
It was very symbolic. It really represented the permanent joining of our two countries in this space endeavor.
Then the second of the 2 Toru antennas that had not deployed properly were attended to, and you can see me on the foot restraint here using the boat hook or pole to release that second antenna, and there it goes. The spool missing the tail of the orbiter by quite a few feet. We then proceeded all the way to the top of the Zarya stack, about 80 feet out of the payload bay of the orbiter. We installed a handrail up there at the top of Zarya, and then also identified 2 exposure trays that were no longer in their proper on-orbit configuration. They probably vibrated free during launch.
You have to look very carefully to see us up at the very top of that stack, 2 small figures working.
After we were given go from the ground to fix those 2 trays, we did that, and then we proceeded back down Zarya, back down onto the node. We finished off our operations on the stack of the station, and then had the opportunity to do a flight test of the rescue backpack, the little rocket rack backpack on the back of my suit. We identified a couple of problems that we're going to fix, and we'll have a fully functional, satisfactory way for a crew member to save themselves should they become detached from the structure of the station.
Sure was a pretty sight, seeing the space station attached to Endeavour, but then came the point in the mission where we had to separate and prepare to come home.
And this next sequence of shots again highlights all the teamwork on this crew that really went into almost every event. There were at least 2 of us, and you'll be able to see here as we separate right there from PMA-2 from the orbiter docking system and begin to back away. When we get to 2 feet, then I'll put in some out pulses which will cause Endeavour to fly away from the International Space Station.
Rick was at the flight controls at the aft flight deck for this portion of the mission and flew Endeavour away from the space station out to a distance of 450 feet and then flew around it 1.5 times, and he did an outstanding job.
We undocked in darkness, but very quickly the sun rose, and this shows everybody. There's Nancy at the front inputting the orbiter attitudes into the Space Shuttle computer system. There's Jerry is closing out the docking system, performing the final steps to secure that. And Jim was assisting with the computers and taking handheld laser marks. As the sun came up, it was very bright in the cockpit, and fortunately the experienced crew members warned me that it'd be necessary to have sunglasses. As we backed away, we just had beautiful views of the space station that we couldn't really see as well when we were right docked with it, but it was just a beautiful sight against the background of the Earth there. And you can see Sergey is beginning the photo documentation. We flew around 1.5 times so that the station could be documented from all sides with different lighting. And those photos will be analyzed by the folks on the ground and used to train future crews as well.
What a fantastic view. What a sense of accomplishment to see an operating International Space Station on orbit.
One point of note, the camera view that you're looking at with the 2 vehicles moving into daylight. We do have capture confirmed. do have confirmation that we do have contact and capture. Now we have this view from Zvezda, now firmly attached to the International Space Station.
Shortly after being in orbit, the first thing we have to do is we have to turn the rocket ship that we just rode into space on and turn it into the spaceship that we're going to have to live and work on for the next 2 weeks. And here you see a bit of a speed up of what it looks like opening the payload bay doors. They're really not quite that quick. I did mention earlier that we get into the rendezvous right away, and here if you watch the OMS pods on the back, you'll see there's the OMS engines light. You can see the camera jolt there from the OMS engines. And eventually those maneuvers brought us around to this view here, which is what we saw a still of earlier, and that was looking up through the centerline camera. Pam had mentioned that everybody has a job to do during the rendezvous, and that is certainly the case. And everyone had a key role to do, and we all worked together very well as a team, and things went just the way we wanted to. We flew around to being above the space station, and here you see us at about 170 feet. We held there until we were in the right place over the ground, at which it was time for us to start in. And then we closed in to 30 feet where we evaluated that target that you see right in the middle. We determined that the orbiter and the space stations were in perfect alignment. There was no adjustment that was going to be required. Here you can see in the cockpit the fact that everyone's working. And here's the, as we're approaching for the final docking, looking out the overhead window past me. I was looking at this scene right here because it's my job just to keep that centered up. And to tell you the truth, I'm glad I wasn't looking out the back window. It was too close. But here we are in the last couple of inches, and you can see the two surfaces come together very well. Inside, there's about a couple of seconds of high-fiving and a little celebration. And then Mike looks up and verifies that the lights, the moting lights on the space station were indeed flashing, indicating that it was in free drift. Bill then took over and was running the docking system and bringing the interfaces close together. And then once that was done, it was time to go to work.
Shortly after we docked, we entered the node, and it's pretty interesting entering a different space vehicle. You know, you saw what it was like getting into the shuttle, and it's quite a bit different when you're all unencumbered and floating. We had to wait for some time for the seals to relax before we actually opened the hatch, and you kind of poked through the window there and got a glimpse of what it looked like inside. That hatch, I'm guessing, weighs a few hundred pounds, but it doesn't weigh much in space. At least it doesn't seem like it. And this is Brian just sort of floating right in. You see how spacious it is, no pun intended, going into the node. And especially after being in the cramped confines of the middeck, which were exacerbated by all the stowage that we had, going into the node was kind of like going into a playground or going outside into a playground. As we sort of one by one made our way in there, as Koichi pointed out earlier, it was very easy to get disoriented inside in kind of a pleasant way. The node being so symmetrical, it was tough to keep straight which way was up, which didn't really matter in the final analysis, and unless you were looking for something that you had put somewhere and invariably was elsewhere when you went to go get it.
Okay, this is Bill and I, and also Pam, working on the in-flight maintenance to replace the space vision unit and also provide the contingency power. Since the ground came up really with a well-thought plan in a very timely manner, and we could do the in-flight maintenance really quickly. So we could do the Z1 installation without much delay. This is computer graphics. It's actually a bird's eye view, although in space there's no bird flying, so it's difficult to explain. But this is how we operated the robot arm to install to the Unity module. And actually the motion is much slower, and we did very carefully and slowly. This is a camera view of Z1. What you can see is the bottom portion of the Z1, which was installed on the cargo bay. This is a final approach of the Z1, and Mike was already inside of the Unity module giving me guidance. And after the installation of the Z1, we started to work inside of the space station. and everybody is in the Unity module here, and a lot of units hanging out. Again, this is the Unity module. As we mentioned earlier, I felt it was difficult to orient myself to know which direction is up or zenith or port or nadir.
Coming down through the station back into the shuttle. This is the shuttle airlock we're entering now, and you can see the two spacesuits poised for the first EVA there. They had been checked out previously, and here's a nice picture of Jeff getting Bill and I suited up to get ready to go out on EVA 1, getting Bill's glove on there. Here's a picture of us getting our tools over at one of the toolboxes that we eventually installed onto Z1. And you can see in space you can orient yourself any way that'll work to get what you need done. Here's a picture of Bill getting the arm set up. He's putting a foot restraint onto the arm. He's attaching that, and then he's going to stand in it and lock his boots in. And he and I switch places on EVAs 1 and 3, getting driven around on the arm. And here's a picture of Bill working on some cables there. This is the SASA antenna that we relocated. Bill's got it in his hands there. He's attached to the robot arm, and I'm assisting him there in a foot restraint. We temp stowed that, and that'll get put on by the next flight to launch in just a few days. This was the part that we were most worried about on EVA-1, and this was the KU band antenna that we launched up on Z1. Bill had to grab that and manually pull it out on the arm, and then I helped him attach it, and then we were able to deploy it and swing it out of the way to make room for the P6 that's going up on the next flight. This was really a spectacular sight in space, watching this big structure swinging out, and hopefully this will make the IMAX movie, and you'll be able to see it in a couple of years.
After EVA-1 was completed, you can see Bill backing up Koichi on the arm, and Leroy's taking over the checklist, and it was time for Mike and I to go outside and start on EVA-2. Here you can see a graphic of the arm operations of what happens on EVA-2. We had to release the PMA from the structure, and then Koichi would bring it around the arm and stick it over the front of the cabin here on the node. And of course, in actuality, Koichi doesn't move the arm that fast. Here you can see Mike and I unbolting it from the structure that holds it, a Spacelab pallet that holds the docking adapter in the bay, and here it's released, and Koichi is starting his arm operations to move it up out of the bay. And as it transitions up the station, the next scene is a nice one at night. A lot of this was done at night. You can see it passing one of the solar arrays here, and Mike is working in the foreground, carrying out some circuit boxes that are going to be used on a later flight downstream. And here it is being attached to the station. This is part of the space vision system locking on to the dots here that help guide it in, and you can see Mike up here getting ready to give directions to Koichi to help stick it onto the node. And this is what's going on inside the cabin. Koichi is, of course, operating the arm, and Pam is operating the computer that drives the bolts and the capture latch mechanism to capture the mechanism. And here you can see the 4 ready-to latches lighting up, meaning it's ready to be captured and then bolted onto the station, and everybody's really happy because it's worked as planned, and you can see here Koichi getting his high fives for the great work that he's done. After it was bolted on, Mike went over and started undoing all the umbilicals so that they could be attached, and I got on top of the arm to move over the nose of the orbiter to help attach those umbilicals. It helps to have kind of a person on the arm as a stable platform and a free floater to help kind of run around and get everything that's needed to do, and with the two of us working there over the nose of the cabin, you can see the cables were done.
We've mentioned a couple of times the IMAX camera, and we do have some payload bay footage from the IMAX cargo bay camera 3D, and we also had a 3D in-cabin camera. And this is one huge camera, and the film, as you can imagine, is just gigantic. And so it takes a lot of work to handle that. And you can see Pam having a little success when she's finally gotten the film loaded. Now for EVA 3, we were going to continue outfitting Z1. In that first picture, Leroy had just released the first DC to DC converter unit, and then he moved that around and attached it to the starboard side of Z1. We had 2 of those, and then there were additional components to move. Here, Koichi is Leroy is attaching the second toolbox that we had carried up on the back of the Space Lab pallet. You may recall there was a keel pin located right here on the bottom of Z1 attached to those 2 lugs. Here it is being repositioned over to this location by Leroy, so it'll be ready for, it'll be out of the way for the next mission. And then Leroy is here finishing connecting the final umbilicals to PMA 3. And at this point, we can see that we've just about gotten most of Z1 configured.
On the fourth and final EVA, we were primarily concerned with getting some tasks done for the following flight, including clearing off the Zenith surface to attach the P6 truss to, and then also to deploy the tray, which is a little difficult to see in the picture. That tray has some fluid lines on it, which will be connected to the lab first and then to the S0 truss. This is the safer DTO that I was speaking of earlier. Here you see Jeff free-floating here. He is attached to a tether, which conveniently just disappeared, so it looks like he is truly free-floating. We tried talking NASA into that, but they wouldn't let us do it. Our first goal here was to just do some maneuvers to get some familiarity with the flying qualities of the vehicle, and then we wanted to demonstrate sort of a simulated self-rescue. So we wanted to get as far away as we possibly could that they'd let us, and then fly a flight staying within range of the person who was always on the end of the arm. And this is a shot of Jeff, whose flight was at night. You can see his 2 helmet lights quite clearly. The target that he's flying to is actually the camera that's being used to shoot this video. And this is the end of my flight. As I approach that camera, you can see this is the hand controller module here, which is Velcroed to my spacesuit, and this is the actual controller itself. And you can see as I put these inputs in, you'll see a result in my trajectory. The controller can either put in rotational or translational movements depending on the position of one of the switches. That whole flight for both of us was even a level above the excitement that we normally have during an EVA. We went into the FGB then after that 4th EVA on the next day, and mostly did a very small amount of transfer. You can see again how it's fairly tight quarters in there. There is a lot of stowage in the closet, but like a lot of closets, we can't get everything we need to inside, so we ended up having to put a lot of it outside. Pam and Bill in this view are attaching a camera target which we use to berth the lab, and then finally Brian, in fine Navy tradition, rings the bell to announce our departure as we leave and close the hatch for the final time on an uninhabited space station.
Well, as I talked about earlier, undocking was a really special moment for us. It was sad to leave the station, but it was wonderful to see all the physical evidence of the work that we'd done. It was a lot like the rendezvous in the sense that everybody has a job to do. I guess it's probably pretty obvious that the only time they let the pilot fly is though when you're getting further away from the station rather than when you're getting closer to it. That's all right. This is kind of a neat shot because you can see that we're actually separating in a way that is not usual. We were separating laterally. That's something that hadn't been done before, and you can see we're pretty excited that the procedure worked and everything went exactly as planned. It was really personally rewarding for me to fly the shuttle this way. You can kind of see I'm making actually some controller inputs using the rotational hand controller. It's not something we usually do. We don't usually change our attitude manually, and so that was just really fun for me to see how the shuttle flew. But here, of course, you can see once again the Z1 truss and the PMA and the antenna. Really, really special.
We're on our way to 17,500 miles per hour as we begin the chase of the station.
Once we were on orbit, we had to convert this rocket ship into our home and workplace. And part of that involved preparing our suits for the launch, or for the EVAs.
Well, the first critical task we had once we were on orbit was to get, obviously, rendezvoused and docked to the station. There you see a terrific view of the shuttle as it approaches in the P6 in the payload bay. You can see it occupies almost the entire bay. That's our docking port on the station. I was a little bit concerned about the offsets in the CGs and the capture performance once we actually made contact. You can see that, unfortunately, a lot of the good things that happen on orbit tend to happen at night, and that is actually sunset on the station. The view you have now, you just saw, was the centerline target that we use to align the orbiter and do the final approach. That is the station docking mechanism on the top and the shuttle mechanism below, and you'll see that scene again here in a second. There's the final view of the centerline target as we get very close. And we'll go back to the outside here in a second. And you can see we're closing fairly slowly, only at about 1/10 of a foot per second. I have to admit I was very anxious about this moment. The potential for failure in the mission was great if we did not dock. So we were pretty excited on the flight deck once it happened. It took a couple minutes to get the hooks driven, and then after that, we were all happy to have this part of the mission behind us.
Well, there we are on the station. You can see it at the moment. The modules all lined up, the Unity and FGB and Zvezda, and at the very back, the Soyuz vehicle. Very shortly after docking, we had to start the arm up so that we could take the P6 out of the bay, and you can see it being taken out of the bay. And we're going to park it high above the cargo bay so that it's in a friendly thermal position. And it's a fairly big object, so with 45 feet and weighing about 35,000 pounds, we had to do it very carefully. And there it is in the overnight park position. And the following morning, I took it and positioned it about 3 feet above the Z1 structure where you see it in this picture.
It's a pretty tight fit getting into the suit. And as a matter of fact, it's a pretty tight fit in the airlock as well. And Brent and Mark did a fantastic job getting us in. It's a real team effort. There's plenty of room outside, though, and here Carlos and I are on our way to work. This is the first flight of the wireless video system, the helmet cam, that gives you this absolutely fantastic view of P6 as Mark brings it down. The motion is slow, but you might be able to see a little bit of it there. We're verifying alignment. Mark drives it down close enough, within a couple inches, for Carlos to drive the capture latch to engage the Rocketdyne truss attachment system, and then we drive 4 bolts to hold P6 and Z1 together.
Once P6 was mated onto Z1, Mark relinquished control of the arm to Mike, and the first thing I did was jump on a portable foot restraint and connect connectors between the Z1 and the P6. This would allow power to flow from P6 to the station as well as data and allow us to command it. Meanwhile, Joe was up high removing these launch restraints that protected the blanket boxes during the launch environment, the high Gs and the vibrations. That would allow me to rotate out the beta gimbal, and Joe did another one later. Fortunately, this happened at night, so this is a view out of our night camera, the B camera. It was supposed to swing out on its own on a spring, but things don't always work as expected, and I had to do a lot of pushing, as did Joe on his, mast when it swung out. Once it was completely out, I crawled out onto the end of the mast tip fitting and swung out the blanket boxes. Each box weighed about 800 pounds, but it was just fingertip pressure to make it go all the way out. At that point, I'm about 100 feet from the bottom of the payload bay of the orbiter.
Well, with Joe and Carlos complete with their task and the ground complete with its activation task, it was time to deploy the first array. We actually commanded that sequence to start from on board the shuttle on the aft flight deck. And you can see the mast come out of the canister, and it's amazing that over 100 feet of mast is folded up into that canister, as well as the solar array blankets.
We had a great view from outside, and the still pictures that we took are absolutely fantastic. Some of the panels stuck together, and they would eventually release themselves, but as they did, you could see the dynamics in the array. They got more and more dynamic to the point where finally, at this release here on the left box in your picture, the subsequent crashing down, if you will, was enough to cause both tension lines on both tension reels, and here it is right there, to come off of the tension reel. You can see the resultant motion in the blanket box, or the blankets. Pretty dynamic. Well, after a hard day of work on top of P6, the translation home and the view was just absolutely fantastic. We followed the handrail highway that they provided for us all the way down to the orbiter, to the airlock. And it wasn't until we got on the side of the node that we could actually see the orbiter windows.
Well, at the end of EVA-1, we had the starboard solar array deployed, not tensioned because of the problem with the tension cable. But the ground worked very hard overnight to give us a new procedure to deploy the port array, and this is the port array being deployed. You can see the same sticking phenomena in the blankets. However, what we did on this deploy was start and stop the mast about every 8 feet and to minimize that problem. And there is sunset on the array, and you can see the spectacular colors that we were able to see on orbit.
It's a good picture to give you an idea of the size of the station now. From tip to tip on the solar arrays, it's about the length of a football field. You can see Joe here traversing across the bottom part of the node, and then you got the shuttle arm up the left side. It truly is a magnificent view, and it's incredibly large now.
This is another example of moving to your work site, trying real hard not to be distracted by the view. The helmet cam really gave you an idea, and gives you an idea of what it is like to be EVA. These are the DDCU cold plates that are used to regulate the temperature inside the DDCU, but they also make great mirrors, and you can see Carlos just turned on his helmet light in the reflection, and my reflection is in the lower right corner. We use the pistol grip tool in many of our tasks, and in this case we're loosening the SASA beta gimbal bolts, and you can also see the Endeavour and Unity and the rest of the station in the background there.
The docking adapter you see will have to be moved on the next mission so they can install the lab. In order to do that, we disconnected many umbilical cables between the node and PMA2, as it's called. We also released cinch bolts off 2 of the 3 radiators that were on P6. Here you can see my reflection in a radiator. These bolts had to be removed before the cinch could be deployed. And here you see a deployment of a radiator following EVA-2.
The first task we had to do on EVA Day 3 was repair the starboard solar array blanket box tension problem. And the ground team just did a fantastic job of developing a procedure for Carlos and me to follow. And here Carlos is guiding the cable in with a tool while I control the rate of the reel rotation.
A lot of people had worried about how hard it would be to do this, so we had a little anxiety as to how it was going to go, but we were very happy to see it work the first time, and there's our enthusiastic response right there. We also had to tear some things apart to be able to get to our work sites. Here we had to remove a panel off the side of the node so that we could install an antenna cable that we would be using with the floating potential probe. So I was hard at work there in this scene.
And Carlos was working so hard that I felt it was time to take a little time off, and I'm waving at the crew inside the crew module. and then enjoying the absolutely fantastic view of the Andes Mountains and Argentina as we went over. The final task we had was to install the floating potential probe on the top of P6, complete with a topping out evergreen tree and a short topping out ceremony.
This scene is kind of sad for me, and Joe will recognize it. It's the view from the top of P6 looking down at the Earth and Endeavour. This was one of the high points that we get, but it was also towards the end of all the work that we had done outside. By the time we finished the third EVA, we had the arrays deployed, the radiators were out, we could flow electricity and cool the station.
Well, it was finally time to go say hello to the station crew. The hatch you see being open there is the hatch between PMA-3 and the node. And that's the shuttle crew actually floating into the station. Shep, Yuri, and Sergey welcomed us aboard very warmly, and Shep, being a Navy captain, observed the Navy custom of ringing the bell as we floated in. After just a quick picture in the node, we actually took the station crew into the shuttle flight deck. We're back in the shuttle flight deck now, so they could get a good look at the P6, their new power module, which they would be managing over the next several months. And that's the view that they saw out the overhead window.
Well, after this, all of us were going to head down into the service module so we could all get together and plan the next 24 hours because we had a lot of work to do. And here you see Sergey beckoning us through the FGB, and we're on our way into the service module that you see in the distance. And the FGB is basically a place where they store a lot of things, and now we're coming into the transfer module, and you can see the service module with Yuri and Sergey already there. And this is basically the heart of the station at this point in time, and we're going to take a little trip into what we call the stateroom, or one of the staterooms, which is where the crew basically have their sleeping compartment. And so this is one of them. It's not much bigger than a closet, but very, very comfortable, and very good about it is the fact that they have a window, and you can see some solar rays there, both from P6 and as well as the Russian modules. And of course, we had a meal together before we set out to work, and had some Russian food as well as some orbiter food.
All too quickly, it was time for us to leave. We had the hatches open just a little more than 24 hours. We accomplished a great deal, and as we left, Shep again observed the tradition of ringing the bell on the quarterdeck as the crew departed. That's the final hatch closure, and we were getting ready for undocking.
Due to the great work of Lonnie Schmidt and his folks, we had enough propellant left where we could actually do the fly around of the International Space Station. And like the docking was at night, the undocking was also at night, and we used a couple of small springs on the docking mechanism to push the two vehicles apart. And then once we got a couple feet apart, we fired the thrusters to increase the rate of separation. It was interesting, looking up at the arrays, you could actually see the arrays ripple as we had fired those thrusters. It was a team effort to do the fly around. I was actually at the controls, and Brent was backing me up. Carlos had the handheld laser, and he was taking the shots to tell me the range, and then Mark and Joe were firing as many pictures as they could. It took us 45 minutes to do a complete fly around. Really incredible pictures. When you're up in space, most of the man-made things you see in space are white or black or silver or gray, pretty mundane colors, but with the huge solar arrays out now, you now added this very brilliant gold, sometimes orange, depending on how the sunlight hit the arrays, and it was a very pretty sight. Let you enjoy the view here for a second.
As we talked about before, we're going to bring our docking port up to touch the docking port on the bottom of the Unity node. And this is a view out we have a camera looking straight up our docking port. And there's me flying a vehicle out the back window, and all of us working to make it happen. a view from service module as we come up, and actually we're doing our tail forward spin around maneuver. And then we're getting closer to Unity, and they're seeing us as closer to them. You can see the lab in the payload bay. We're much closer now, probably about 20 or 30 feet away. The bottom of the docking port's being illuminated by the lights that we have shining up to keep it in view. Here we come down to a couple of feet away. You see the orbiter docking system ring extended on a couple of spring shock absorber looking things, and you'll see why in just a moment. And that's the aiming cross that we use to fly up and keep everything in the center. Actually, there's quite a bit of forgiveness in this. You're allowed about 3 inches and 3 degrees of error as you come together. And then the ring is retracted and brought down so that the two surfaces are touching each other, and then there's some very powerful hooks that emerge from the lower surface and grab a hold of the station and pull the two vehicles together and make a hard mate. And here's the view out the front windows after we're docked. We are all over that station, or it's all over us.
And then we came inside. Here's Shep ringing the bell, welcoming us inside, and we're looking around the node right there. So for those of you that have worked on the node, let's see what we can see in here. Well, mostly us and cables. There's my centerline berthing system camera right there. So the lab will go, attached lab here is what it says on the outside. PMA first, then lab, as those of you who wrote that. So we all got on board, and here's the obligatory photo op. And then we went to work. Had to get the arm out, so there's the arm, there's the lab, and the rest is history at this point, which I'm glad of.
Yeah, part of the fun of getting ready for an EVA is wearing the funky underwear, actually. And actually, this is the underwear that we wear under there. It has liquid cooling lines through it. And then you don't really put the suit on, you get into it, as you can see. And as you can probably see how tight it is in there, but one of the advantages of being in space, once again, is that Roman can go all over the airlock to get us dressed. And that's what he did. And like I said, he did a fantastic job of that. And you can see he actually can put his get up on top of the ceiling there to put on our helmets.
Okay, we're emerging into the payload bay for the first EVA, and Marsha's got the docking port ready to move. And I guess you can see her moving the docking port, the PMA, off the front of the node, and she's moving it into position.
This is the part of the Z1 truss where the PMA was going to go. Here's Tom out here going, Mom back, and here's the PMA on the end of the arm. And here's the view from his helmet camera as he gets it ready to be in position. Then I got off of that, came down and grabbed the lab, and Beamer gets out of the way. Smart man. Pulling the lab out of the bay here. It's the hard part is done, and I've picked the rate up. You can see it took about 20 minutes, 15-20 minutes to flip the lab, and we can't show you that, so we're going to go through it a little bit faster here. They put the lab in 180 degrees out, and I've been doing nothing but trying to explain why, and, you know, pick a reason. I don't know. Here it is at 90 degrees, just about 90 degrees, and the best view was what Tom and Beamer had outside. So here's the lab 90 degrees to the payload bay being shot from up on the truss. Continue to flip it around. It just was amazing, and so the tourists are always taking pictures of everything. almost all the way around, and there it is, all the way around and getting ready to be put onto the node, and it just slid in there as happy as could be. There it is, all attached. Yay is right.
And here's after signing the paperwork, we opened the hatch, and then we took a camera in first to let the people of the space program and of the world take a view of this new piece of space hardware first. And this is the way it looked when we opened the hatch. Very clean, pristine, And as I said, the air was clean and cool, and just a wonderful, looked like a wonderful place to be. Here we are coming in to take a look.
Like I said, first thing that happened, Sergei said, "Watch this," and did his 4-point roll. And the commander, not to be outdone, that poor pilot just can't figure out which way is up there.
And again, we talked about moving the rack around, and when something gets in your way, you just kind of float past it. Lots of cables, cameras, you name it out there as we're moving this thing in place.
Here we are on EVA 2, moving the PMA down to the end of the lab now. This is the view from the centerline berthing system camera. And this is the target that I used. I was looking at my own reflection here in the mirror on the PMA, which was the best cue that we used at all. There's the PMA getting ready to get attached to the lab.
Once the PMA was attached to the front of the lab, I got to work on the arm. Marcia had given me a good place to step into it, and here we are removing the PDGF, the grapple fixture, from the orbiter sidewall. And then I was able to pull that away and then take the ride up to the lab to the installation point. And then Bob met me there, and with our 2 pistol grip tools, we were able to bolt it into place and install all the wiring that would get it ready for serving as the base of the station robotic arm. So we're finishing up that task right here. Then, as Bob mentioned, we got the window shutter installed. That was his job. And here he is opening the shutter for the first time. And there's a blanket that protects the window during launch, and so the 2 of us peeled back that coating and looked inside Destiny from outside. What a moment this was for us to look in and, hey, here comes Sergei. And the whole crew was in there, and they were able to come over and say hello. They also asked us to come back in about 20 minutes. It was dark outside, so we just have our floodlights illuminating it, but when the sun came up, Bob came back over for another photo op. That's his gold visor, and in it you see reflected the window of Destiny. And then they brought over the IMAX camera. So here's Bob locking into place with his body restraint tether, and Sergei was the camera operator for this photo pass, and he says, "Stand by 1, I'll have the camera right back." And there's the 3D IMAX camera, and we've screened some raw footage of this camera, and the view outside into the payload bay just knocks your socks off. Can't wait to see the movie that comes out of this work.
The third spacewalk was my turn to ride the arm, and the primary purpose of this spacewalk was to move a spare radio antenna that was connected to the sidewall of the payload bay. And there we are. I'm on the arm on the upper part of the picture, and down on the lower part with the red stripes there's Tom. Tom unhooks it from the payload bay, I grab it, and off we go. And Marcia's taking me for the ride of my life here. As you can see, it was quite dark, but I ended up about 20 feet above the lab and holding this 250-pound monster, and then put it down on the Z1 truss so we could stow it there. And that's a spare, just in case the primary breaks, the station crew can use that one. Our next job, as we talked about with the slides, was to go up the power truss, the P6 truss, and take some pictures of a radiator being deployed. So this is actually a picture of me translating up there, and then we watched them take the radiator out. And they're actually controlling this from inside, and we were just doing photo documentation. And there you see on the left, the radiator deployed. And so then we continued up the power truss, the P6 truss, and started to look down. At this point, we're about 130 feet up from the payload bay, and you can look down the truss, you can see the lab off to the top, and then we, after that, we came back down for some more work on the lab, and that's a picture Tom's taken of me.
Well, we already saw a slide of exercise, so here it is in motion, and I think we talked about how you get a lower body workout, but we haven't talked about how you work out your abs. Then there's the stationary 4-point roll.
That's been cut. Well, we're going to take a tour of the station now as it was when we left it. We're leaving the service module. There's their central posts section with all their control We're coming into the section that connects the service module to the FGB. This is a hatch right here with a cover on it. This is the FGB, this cargo stowage module right here. Behind all of these panels our things are stowed. Sometimes they're out in the aisleways here. Right here is where Yuri was sleeping on the wall. There are handrails everywhere. This was actually a pretty clean module, you stowage guys. Look at this. It's the way it needs to be. This is the way they move their air back and forth between the different modules here. This is the section that now connects the FGB to the node. Here's the PMA that we're coming through here. This was the hardest turn to make. You get up ahead of steam and you'd smack right into the top of that. They had one of their spacesuits stowed right here. Now we are in the node. This is the lab, which we have seen before. And so we'll just take a turn here and head for the shuttle. Down through this PMA, which was our front door, there is the hatch to that. We're now in our airlock. We are moving air back and forth between the shuttle and the station. Here's the hatch. Here's one of the EVA suits. Another 90-degree turn here through the airlock, and we're in the middeck.
Well, unfortunately, our week docked with International Space Station Alpha came to a close, and Shep rings the bell, and it's time for the Atlantis crew to leave. And it looks like I'm waiting for Shep to ring the bell. I'm actually waiting to figure out how to do this without hurting myself again. Following me is Roman, and the rest of the crew follow after him. And then finally, when it's time for Marcia to go, and I think this crew was sad to see us go. There was another crew coming up in 3 or 4 weeks, but they don't get a lot of company up there. This is a view of the Russian solar arrays and undocking.
As we back away here, you could see the station looking like it's moving, when in fact we're the ones that are leaving it. Out the window out the back, you can go ahead and see part of the PMA as we slowly back away. For the rendezvous guys that are here, it was a tremendous honor to get to do this, and it flew fantastically. It was really great. Up here you could see what was a laser, that we had a handheld laser to go ahead and get distance and range. You could see the laboratory that is now in place, and you could see the window. And that was the window shutter that's behind there, and those guys were looking out at us as we backed away, and that's where we used to be docked. A great view taken from the station as we fire some of our RCS reaction control system jets, maintaining attitude as we back away. You really can feel those things as they pulse. We slowly backed away to 450 feet. And here are some views. As you could see, we talked about those gold arrays up on top of P6 as we slowly maneuvered in a half a lap around the station, taking a look at our handiwork. And it was really quite the thrill to get to do that. Although every once in a while I had to ask for some help because everybody was blocking my view through the window taking pictures. Great shot as we came over South America and the Andes here. And you could see the shadow of the shuttle on top of the station as we said our farewells.
First third of the rendezvous is controlled by computers, automatically controlled. The middle third of the rendezvous, we use computer guidance, but we manually fly, going exactly where the computers tell us to. And then for the final 1/3 of the rendezvous in this sequence here, we're mostly looking out the window. We do have some tools that we use, a laser rangefinder system and a rendezvous radar to give us the very precise information needed for the rendezvous. The vehicle performs so well, it's so well designed by the contractors around the country that you're able to put it within inches of where you need to. although you're flying at a speed of 17,000 miles an hour, the relative speed is about a tenth of a foot per second as you're finally closing for the docking. Yuri, of course, is very happy because we have gotten to his home, and here we are opening the door.
And we're all waiting on the inboard side of the station for the Discovery crew. There's Sergey opening the docking hatch there. This is kind of the food frenzy when everybody's flying around hugging each other inside. This is now our quarterdeck on station. We have a bell in the upper right corner over Paul's head there, and this is where we gong everybody on and off. It's kind of a shipboard tradition that we hope will be continued. This is just an external view looking up the stack at the lab and station.
And we had a lot of work to do. This is getting ready for the first spacewalk. That's Susan getting in the lower part of the spacesuit. You can see it takes several people to help you get dressed. And this is Jim Voss getting in his glove, and again Susan putting her helmet on. This was one of two spacewalks that we performed. Each spacewalk putting critical elements. And this is coming out of the hatch. Jim comes out of the hatch. We have a thermal cover that's on the outside. They already opened the inner hatch, and he attaches himself to the arm and starting to prepare to put many modules on. One of these modules here we had to move. It was already up there, but we need to put the cargo module, the MPLM, there, so we had to move this pressurized mating adapter to another place. So Jim and Susan got that ready from the outside by taking cables off. This is another cradle assembly, kind of a building block that we put on the laboratory module to later attach another piece of space station. So we're stowing that there, and another crew will come up and continue the construction of space station. And you can see it, as it looks, it's very easy to move some of these large masses that are a couple hundred pounds, sometimes thousands of pounds across. And this is Jim and Susan on the laboratory module installing that cradle assembly. And this is the view from inside. We have robotic operators, and for the first spacewalk, I was the person inside calling out the procedures to Jim and Susan. This is Susan manipulating some wires. These are actually a wire tray to connect up, some rigid umbilical it's called. And Andy actually helping moving the arm around.
At the end of the EVA, we had the task of moving the module you see in the upper part there, the dark shaped colored module. And I used the arm to do that. I brought the arm in and grappled the module. When it was secure on the arm, we released it from the side of the station and then proceeded to drive it around the side of the station to put it on the port side, or the left side here, as you can see. Moving this module with the arm was a relatively easy task, even though it weighs many thousands of pounds. It may be weightless, but it has mass. To help me align it with the station for the reinstallation, Paul set up a very sophisticated computer system, which you can see him doing here, so that I was then able to drive the arm on, knowing confidently that it would be positioned. Once it was on and latched onto the side of the station, we were able to release the remote manipulator system from the module. The next task that came the following day was again using the arm, and you can see here it's preparing to lift the module that you see in the center of the picture in the payload bay up out of the payload bay to install it on the station. This module weighs about 20,000 pounds and contains about 4 tons or 9,000 pounds of supplies for the second expedition. We had to bring it up, and as you see there, mate it to the side of the space station so that the expedition crews would be able to access it and start unloading it.
Here I am opening the hatch with Jim Voss and Yuri helping, and once we're inside, I guess part of the we missed a cable there that we needed to power up the inside of the MPLM that happened to be in the MPLM before we hooked up. That was kind of a surprise, but we quickly recovered. And inside, Jim's moving a rack here, You can see that the MPLM is really a spacious module. It's a lot bigger than we were ready for. It's just a really well-built, spacious piece of gear, and it's going to serve us well in space station, hauling stuff up and down, I'm sure. And here's moving one of the, I guess we moved about 6 racks. This is one of them that we moved from the MPLM into the lab. It was tight, but it was very easy if you went slow to control it and make sure that, I don't think we even put a scratch on a rack doing that.
And we were going out for a second spacewalk. This time Andy and I get to go out. And here you see us suited up in getting ready to suit up, checking our cameras and our equipment. And once again, here's Andy getting ready and getting the lower part of his suit on, and myself doing the same thing. And you can see the different color codes. Mine was a candy stripe, Andy was a broken barber pole, and you can see that's how we're identified. And then it's a tight squeeze to get up into the suit, but much easier in zero-G than down here on the Earth. Some things do get easier in space. And again, we have a lot of equipment floating around and a lot of people helping us to get ready and into our suits. And now it's my turn to get in the suit. You see some of the other equipment we're wearing is those long johns have liquid cooling tubes, and that helps us keep cool during the spacewalk. Outside on a spacewalk, it can be minus 250 degrees and plus 250 degrees, all kind of at the same time on different areas of the space station. And here's Susan, who was our IV, or the person inside who choreographs and helps us with our procedures getting ready. And Sergei Krikloff also helping suit us up and getting the helmets on and checking and rechecking to make sure that all the connections are secure. And once again, we come out the door, and here's Andy coming out. And we actually came out at a night pass, and you can see by Andy's helmet lights that they're on, and that helps illuminate our work areas. Andy's hooking up a tether. We always tether ourselves and our equipment to make sure we have control over it. And that's Andy and I working outside together, and I believe this was close to the end of the EVA when we were gathering our tools. This was the power tool that you guys keep hearing about that I helped design with a bunch of people up at Goddard, and I finally got to use it. Although it was only on 2 bolts, I wanted to take more of the station apart with it, but they wouldn't let me. And this is one of the stowage platforms that Andy and I removed from the shuttle, and Andy would be up on the arm installing it.
And here you see I've received that platform from Paul, who's underneath the sill there, and my job is to carry it up while being lifted on the arm up to the side of the space station, where there's a trunnion pin where we can install it. And here you see I'm just holding it as the arm slowly lifts me up out of the payload bay. And as you can imagine, it was a great sensation to be suspended over the shuttle like that, carrying this device. Here we are at the top of the station, near the full reach limit of the arm, and Paul and I are installing this device onto the side of the station there. This will enable replacement and spare units and components for the space station to be installed and stored outside for later use. There you see a view of the lab with someone in the lab window. The next job we had was back in the payload bay. I had the task of removing this large replacement pump unit from the platform that we'd brought it up, and actually going to take it up and put it on that stowage platform that we had just installed a few moments before. This pump unit weighs about 400 pounds, but you can see it's in zero gravity. It's really fairly easy to remove it. And once again, the arm lifted me up out of the payload bay and carried me around up towards the lab structure high above us, so that we could install this and mate it to the side of the space station where it still is, and it will be available there for future crews to use to replace other pump systems in the event that there's a failure. And this is just a view coming up past the lab window up to the installation site, high up on the side of the space station. Here you see Paul attending to cables that were also routed, and he's making his way down past the work site to another work site where we had to do some cable installation.
And the other cables that we have to install are for yet another crew to come up and put on the robotic arm. These are a tray of cables, a rigid umbilical we call it, and we had to actually open up some of the panels on the laboratory, and you see Andy off the arm there connecting some of those cables. And then the next site was Andy going up to the P6 here, all the way up this truss to the top of the station where the solar arrays are located, and we were going to do some troubleshooting on those. One of the solar array latches had not locked. They had 3 of 4 locked, which were good enough, but they wanted to get that 4th one, so they let Andy and I go up there, and Andy is translating up there in the day. I was working on something else and came up at night, so the view that Andy had and we have of him is pretty incredible. It shows you just how large the station is compared to a human. And this is Andy coming back into the from the top of these solar arrays and showing us coming back in, inventorying our tools, making sure we have everything with us and we don't leave anything outside, because this was the last spacewalk, and we have to secure the equipment. And we had some film left over, and we were able to start taking a few pictures of ourselves. We try not to come in with any film unexposed.
And this is the closure of the EVA, crawling back into the hatch. And even though you're weightless, of course, you have a very massive, bulky suit on, and it just gives you some idea of the difficulty you have moving through confined spaces when you do one of these EVAs. And here I am pulling the cover up as the first stage of closing out the hatch to terminate the EVA. While the EVA was in progress and after the EVAs, we continued with the transfer operations in the MPLM. And here you see Expedition 1 and Expedition 2 crew members transferring bags of equipment from the racks that were in the MPLM and carrying them over to station, and also bringing back old equipment from the station that was stored in the module for return to Earth. And here you see Expedition 2 crew and Bill Shepard down there loading bags of equipment. Once the module was complete and fully loaded for return, we demated it from the side of the station using, once again, the robotic arm, and carefully carried it down back into the payload bay of the orbiter, where it was latched in for the return trip back to Earth. Once we'd put it in the payload bay, we then able to release the arm from the module.
This is the next day, and this is the handover that Yuri and I had to change command on board. And believe me, this was a pretty electric moment up in space there. And we had getting ready to close the hatch. This is looking down, well, actually up into station, sorry. And the docking adapter hatch here from the airlock side. Glad to see the commander's finally doing some work on this mission.
This begins the scenes of the undock and flyaround. As you can see, it gets pretty crowded in the aft flight deck. We basically had 6 people on the aft flight deck using the windows and all the controls, and Wex was in the front backing things up, so all 7 people up on the flight deck. Pretty spectacular. We did the undock at night, and you can see it just really gently slides away from the station. And we actually back away and then go to a different mode and start what's called a flyaround. And we basically did 1 1/4 laps around the station. We started out in front of the station in the direction of motion, and then went up to the top so we could see the space station below us, and then actually did a full lap from there to go all the way above it to underneath it, so we were looking directly up into space, and then back up to the top again. This is pretty critical to get around. We actually do a complete photo survey of the outside of the International Space Station as we do this full lap, so we can see any changes that have occurred, anything that's going on.
This star you're looking at now is brilliant and becoming more brilliant all the time. That is the space station, and that's what it looked like to us during the rendezvous. You'll notice the flashing out the windows, and those are the jets that we're firing. We do a number of those during the rendezvous to make sure we can put the shuttle, as you see it closing down the station, in the right portion of the sky. I tell you what, the station is very intimidating. It is so large that even when we're 1,000 feet away, you feel like ducking that you're going to hit it. You can see our payload bay that Chris described earlier here with the shuttle. This shot was taken from the expedition crew as we're closing up. And I'm sure it's a little bit scary from their vantage point as well, with this big space shuttle, 250,000 pounds approaching from below. We're lined up now with the docking module closing on in. This is a target we use, and we make sure it's centered and all the alignments are flown out so that we have a successful docking. Here comes the docking. Station is coming from above. And watch the dynamics. At 17,000 miles an hour, although that was at 0.1 feet per second, there are some dynamics between the two. You saw this photo earlier. We're very excited to be there, and we were dying to get the hatch open.
Well, as was mentioned earlier, this was the most complex robotics flight in the history of the shuttle program, and it began the day after docking with the first of several difficult maneuvers. Seen here is the shuttle robotic arm, which is like a big crane, and I'm operating it, and I've grappled and lifted the cradle containing the space station arm out of the payload bay. As I lifted it out, it was just a magnificent sight passing over Baja California. I twisted it and brought it forward, overhead the shuttle cockpit into a position where we could temporarily install it on the International Space Station.
While Jeff was doing all the good arm work, Scott and I were downstairs getting dressed. You put them on the same as at home. You put on your pants, you put on your shoes, put on your jacket, and then here's in the airlock with John and Yuri helping Scott and myself get into the final stages of the spacesuits. Gloves, helmets, you can see our Snoopy caps, everything getting ready to depressurize and head outside. And it is like a chick coming out of an egg there as you open up the hatch and poke your way out and look at the world below. The two of us getting everything ready and starting to climb up on board Alpha, on board the International Station to assemble the arm. Lower right is Scott installing that UHF antenna that Umberto mentioned. I'm riding the other arm, pulling up out of the way, and watch Scott here in the lower right. Nice mechanism built in a couple different places around the States to give the station space-to-space comm capability. And then it was time to bring the arm to life. I'm removing a bunch of blankets that kept it warm while it was unpowered. And then if you look in the lower right, Scott's driving a huge power drill called a pistol grip tool. I'm riding on the other arm. And the purpose is to release the huge bolts that held the arm during launch. We called them super bolts. They were about 3 feet long. They look sort of like arrows. And so we put them over in that thing below my chest over there called the quiver, putting the super bolts away one by one.
Well, if you've ever dreamt about what it would be like to do a spacewalk, this is it. This is actually what I saw at the end of the Space Lab pallet as I was about to lift up the booms of the space station robotic arm. It took a considerable amount of force. Here's a different view of it. I'm on the left, and Chris is free floating on the right. Weighs about 140 pounds of force required to pop that up, and you can see it's a massive structure. It's 60 feet from end effector to end effector on the arm, and weighs about 3,000 pounds. You're going to see Chris back on the robotic arm, the shuttle's arm, with Jeff driving it, and we're going to unfurl the arm at the midway point, and you can see it's just a huge structure. And then we have another view of Chris at the end of the arm, and a very rare view of our own orbiter. There's the nose of the shuttle Endeavour from his vantage point. We then had to insert 8 very special bolts that we called expandable diameter fastener bolts. And these things required a considerable amount of force. We used the pistol grip tool that Chris talked about earlier. Used those and found that they weren't quite enough to actually rigidize the arm in place. So then we had to use brute strength and manually ratchet them. Here's Chris's pistol grip tool, and you can see it kicks back a little bit. In the lower left, you can see me actually manually ratcheting those bolts tight. And this is one of my favorite shots. It's a picture of Susan looking out of the fishbowl, or maybe us looking back in, but rare view of folks on either end of the lab.
Thanks. Well, after the first spacewalk was behind us successfully, we got to ingress on station. We'd been there for 2 days, and it's really exciting. I've been to the space station before a couple years ago, but there's a whole new dimension when you get an ingress with 3 of your friends that have been there for 6 weeks. And it's actually somewhat of an emotional happening, and you'll get the flavor for that. But it really is a great time and a great part. It was really great for us to be part of the expedition crew as we came on board. Here is Yuri. He recently had docked a station himself. They relocated the Soyuz a week before we got there, and he's pointing that out to us with his model. Here's Jim Voss and Susan at the robotic workstation, who have been doing a fantastic job along with Yuri up on the station. We could not have been more impressed.
Well, after 4 days of being on the shuttle, we were more than ready to go into the bright, airy station where you can fly like Superman. And we're going to follow Scott now as he takes us on a tour of the space station. At the left of the screen, you can see a yellow dot that guides you. We're now entering the American Laboratory, or Destiny module, which, as you can see, is just jam-packed with scientific apparatus. From there, we go into the American Node, or Unity module, which has 6 huge hatches which connect various pressurized elements, and there's Chris at work. And we're going to follow Scott through the next wall, and you're now leaving the American sector. We're entering the Russian FGB, or Zarya module, which has a different feel than the American modules, and it really brings back the heritage, the long heritage of Russian space station flying. This was the first module of the space station. It's now used mostly for storage, and behind these walls are cupboards, basically, and it looks like a long square tunnel with carpeted walls. Then we move through another sort of an airlock type module into the last major pressurized element on this long string, and that's the service module, or Zvezda module. You'll see Yuri and Yuri there talking pilot talk with their hands and talking about how nice the launch was. And then as we pass them, we move into the kitchen of the service module, and there's the kitchen table on the left. Jim Voss and Yuri have staterooms on the right and left, where Susan has her stateroom in the laboratory. And then finally, we move into the lifeboat of the station, or the Soyuz entry vehicle.
Raffaello, in the Endeavour cargo bay, we removed the umbilical providing power, and in preparation to lift MPLM up. Moving these 20,000 pounds, it was quite a challenge, and Scott and I were maneuvering the robotic arm. When the MPLM was close to the station, then we latched with 16 motorized bolts. And this is the inside while we are doing unloading operation. We like to call this controller chaos while we are trying to stow all the items that we are returning to the ground. We transfer also experiments, and this is one that we transfer from the middeck of this Endeavour to the US lab, our laboratory space.
With Susan and Jim flying, this is where you operate the arm from, and this is the very first move of the space station arm, the Canadarm2, lifting the first of its huge joints up and out of the pallet that brought it up. With Jim and Susan, you fly it purely looking at the camera views inside and reaching around the side of the lab and over top of the shuttle to grab onto the side of Destiny to make it permanently part of the space station.
Well, our work outside wasn't done. We went out for another EVA on the 6th flight day, and we're getting set up to basically reconfigure all the power so that the new Canadarm2 could live and work on the space station for the next 10 or more years. John and Bones were in that flight deck of the orbiter keeping us on the timeline and driving the arm. And this is a neat shot of actually mating some of the power connectors that we use to power the arm. You can see that it's actually fairly challenging work. We're wearing a very thick pressurized glove. I'd liken it to trying to do brain surgery wearing a hockey mitt or a baseball glove. It's definitely very different than working in your own workshop. Some of the connectors were very fragile. We had to be very, very careful because they were made of fiber optic material, so I had to go very slowly and be deliberate. I don't think there are words in the English language that can describe the view. We certainly tried during our EVA, but here's a neat view from Chris's vantage point up on the node, looking down the whole stack about 200 feet towards the Endeavour shuttle. We had one other major task, which was to deliver a spare electronics unit. You can see Chris in the background there. And I had a beautiful ride on the end of the arm with Jeff at the wheel of the arm, and just a unique vantage point to see this from. On my left, you can see Chris and his maple leaf on the left side of his suit, and we click this new avionics unit onto the side of the lab. And like good tourists anywhere, Chris takes a couple of pictures for us here, some happy snappies, and then we take our last good look at planet Earth, and it was time to call it a day after about 15 hours of spacewalking on this mission. Mission accomplished, and as you can see in the next scene here, we have an empty payload bay.
Right now you are looking at our great commander, countermeasure, gliding through the lab, and now we are in PLM, where crew members had a fun opportunity to exercise in zero gravity in their free time. As you can see from this video, we achieved pretty good results.
Who's next?
The second spacewalk had powered up Canadarm2, and so it was now ready to hand off the pallet. We'd done a lot of work with the folks on the ground to get a good configuration, and I reached up with the shuttle arm and grabbed a hold of the right-hand side, and then the station arm backed away, a kind of, for Canada, a very historic handoff from the old arm and the new arm together.
After good teamwork, it was time to say goodbye. It felt sad to leave the station. Here comes the moment of closure of the hatch, and we said, "See you guys on the ground."
Well, after 8 days docked to this beautiful space station, it was time to leave. We do that by releasing some hooks that separate us, and we're pushed away very gently by some big springs in this mechanism. And we glide away at about a tenth of a foot per second. We fire our thrusters, very small thrusters, and increase that rate a little bit, but it's a very smooth and slow, very graceful movement away from the space station. And I can tell you at this moment, I was both very sad at leaving and also very proud to see this picture and the completion of our critical mission. We undocked over the Pacific, and about 10 minutes later, I looked down at maybe 100 feet out, and we were gliding over the Colorado Rockies, where I grew up. A very neat experience. We continued then up over the continental United States, up over Canada, which was very fitting that we pass over that great country as we depart. And I have to tell you, I looked at this, and there was a little bit of a conflict in my head as my brain said this is not possible, but my eyes were seeing it. And I can tell you that it's really there.
Here's our payload bay with, again, the gas tanks and the airlock that you've already heard about. And Steve, the excitement gets a little closer. Janet's getting ready to run the mechanism, and Jim's shooting the handheld laser. Now, if we saw this happen in this kind of time, we'd all be screaming at Steve. This is like twice real time, but this is a perfect dock. And then the obligatory high fives for a job well done. This is a really good job on the docking. The next thing after mating is getting some leak checks between the two modules. We get to stare at each other through this 2-inch window, which is pretty exciting. And you know, it's kind of like let me in, let me in. And this is an awkward situation here. It's like, how do you hug a guy when you're upside down, the other guy's right side up, and you don't know which one's which? That's Steve and Yuri exchanging congratulations. And again, none of us had been in station before. This is Steve coming into the station for the first time. It's got that new car smell to it. It's a little different.
One of the real challenges we had for the first EVA is that we had an integrated operation with the station crew and us, and we hadn't trained with them for 4 months. And this just shows the pre-flight briefing that we did. We spent about an hour going through all of the different dependencies of the 2 robot arms. Here's Susan actually operating the station robot arm, while Janet and Steve were back on the shuttle operating the shuttle arm. And again, this was the first use of the station arm, and with its sort of slow start with respect to some of the computer problems, we were prepared for any number of different contingencies that could go wrong. And Jim and I were down in the payload bay preparing the airlock for unberthing. And this is a shot of Jim installing his foot restraint. Jim was working on the arm, and I'm down here, you see in the lower part of the screen, releasing a cable. And this is just a graphic depiction of taking the airlock up there. And Jim and I had a really tight choreography. As I mentioned before, we were a race against time for the water lines freezing up or our suits running out of consumables. And the choreography worked out so well that actually when I released this cable and went to hand it up to Jim, he was actually coming by on the arm, and I handed it off to him on the fly. And so we actually had our times down within, you know, literally seconds of what we had hoped for. And then this is Susan getting ready to mate the airlock to the CBMs. Jim and I went up there and were in position to give her guidance commands if she needed them. And then once the airlock was attached, Jim and I got busy with hooking up the heater cables and then preparing some of the fixtures for the next EVA. And this is us coming back at the end of EVA 1.
As with all other modules on the space station, ours was given a name, and here it's being christened as the Quest module. We are not responsible for that name. Headquarters is, so you'll have to ask them. This is again showing the vestibule outfitting, where we're taking some of these lines and connecting the airlock to the space station itself. You see Jim Boss there helping us out, and Yuri, as I said before, we're operating as one team there. A lot of the stuff going on inside, but here we have a very nice picture of Italy there in the background. You can see the boot there at the bottom. Now we're getting prepared for EVA 2, and as we've been mentioning all along, it was quite a choreograph between the 2 arms moving at the same time. We have one stowed over there, the shuttle arm, as you see, while the space station arm is getting ready to hand off the tank to the space station, or to the EVA guys. But in reality, we had both arms moving at the same time. And you see the shuttle arm over there on the left side. The station arm is now coming in for the grapple for the first tank. And now both arms are moving. Mike is on the shuttle arm over there coming up, while Susan is moving the first gas tank up to position. Mike is now there near the top, getting ready to jump off and climb on over to the node and then on over to the airlock, where he and Jim will accept this tank.
And as you saw earlier in the slides, here's another shot of Mike and I taking the handoff from the arm, and here's the arm actually pulling away, and right at this moment we've got the tank in our hands ourselves, and we're the only ones holding on to it, and we're bringing it down onto the latches. This is also like the docking. We would have been screaming at each other if it had gone that fast, but we'd sped it up a little bit. Once we got it attached and locked down, then Mike opened up the valve that flowed the gas to the station, so the nitrogen and oxygen was now available. While he was doing that, I went off to get the next site for the next tank ready for the next delivery. And as you can see here, we've got in EVA 2, we had the opportunity to get 2 tanks on, which was a nominal plan, and we had enough time to get a third one on, which gave us a little extra time on EVA 3. And then as we finished up the day, this is a nice view looking up into the terminator of the Earth. Now, once we got on orbit, it's time to outfit the airlock. And here's the crew opening up, and as you can see, there's a lot of stuff in the crew lock right now. We still had a lot of outfitting to do. Mike's in the crew lock. We've got the crew lock bags with all of our tools in it. And then it was time to get ready for EVA 3. And Scorch here, is, as we mentioned earlier, was our choreographer in all of this. He was suiting us up, making sure we had all of our tools, making sure all of our systems were ready, making sure we were ready, turning on all of our equipment on the suit as we were getting ready to go out the door. And then as he stuffed us into the crew lock, he shook our hands. There I am with my head toward the equipment lock, and Mike's got his head up to the other side. And we almost took Scorch with us, but he's a little bigger than both of us. So he closed the door, shut the garage door on us here. We depressed the airlock and then started the EVA 3. And as you can see, that on EVA 3, we were putting the last of the tanks on. Again, this is animation of the station robotic arm as it's bringing the third tank up. And Mike?
Yeah, this is a view from the elbow camera of the shuttle arm that traces the trajectory that the station arm would make with the high-pressure gas tanks. And then up in the far left corner of the screen, you can see the hatch. And as it turned out, we were delayed a day because of outfitting issues. And we ended up coming out the door on the same day of the anniversary of the first moonwalk, which we didn't even know until the Capcom made a speech about that. And this is a shot of me coming out of the airlock. One of the neat things about this airlock is you come out and you're facing straight down. So as you exit in the shuttle, you go into a nice payload bay, and here you're dropping straight down. Looks like you're skydiving from 250 miles up in orbit. And if that scares you, you can quickly switch your reference frame and look at structure. This is a shot from my helmet camera, which we also call the monkey cameras, but here we are looking straight down at the payload bay. This is me riding the arm down to release the gas tank. And then on the inside, Susan and Yuri were busy flying the SS, or the station RMS. Here's a shot of Jim and I removing a thermal cover that was on the airlock to keep it warm until we got ready to get the tanks. And when the tank was about 10 minutes away, they gave us a call and we removed the thermal cover. And here we are taking the handoff of the tank. And then after that, we scaled the truss to go up and look at the solar arrays. And here's Jim and I flying in formation. We didn't train heavily on this task, and there's a whole bunch of little things that you could really mess up there. So we were very careful to move slow and not undo the success of the first two spacewalks.
So after 9 or 10 days of really full schedules and hardly ever going to bed on time, we decided it was time to have a little party. We went over to the SM module. It was bedtime, but it was well worth it to go ahead and have a meal together, kind of a celebratory event after making sure that everything was done properly, everything worked, and so everybody was very relaxed. And so we had a really nice meal on station with mostly the Russian food, which is just excellent. If you haven't seen the water bubble tricks, this is astronaut's prime means of enjoyment in space, or entertainment. You can see the air bubble trapped inside a water bubble here. You can see Steve's face is upside down there on the outer water bubble, but on the inside, in the air, he's right side up again. So Yuri's taking some dental floss here and removing that air bubble outside the water bubble. Now you see the inverted pictures again of the people in the background. And if you don't get out of the way of that water bubble in time and you take it right in the face, it's quite a shock. Anyway, this is what it looks like if you're doing a fire drill on the space station, taking a tour from the SM module through the FGB, where you can see all our transfer items here waiting to be transferred back to the shuttle. Skimming through this long, skinny module, the Russian module is right below us. They're going right now into the node. We're going to take a quick peek to the airlock to the right and back right through into the lab. And if you keep going straight through, you'll end up inside the shuttle.
This was a sad part of the flight. You know, it almost brought a tear to my eye anyhow. This is the final farewell to the Increment 2 and our stay aboard station. This is a before and after shot. This is the two pieces together. And this shows, if I would have done it right, what it was supposed to look like. Yeah, it actually went pretty well. But we fly out along a line of sight, pretty much a reverse of how we came in, out to about 400 feet, and then we do this circle more like an egg all the way around the station. We survey all the parts and take a look at it from all different angles until it gets really dark and scary. There's a docking target on the left, and then our mating mechanism starting to separate. You can see a little bit of ice bouncing away. Either that or they were throwing coins at us from the station as we separated. And here's the flight deck. Like I said, this time I got to swap with Steve, and he's over on the left-hand side screaming at me the whole time. Here we are separating out. There's Jim's big head. I couldn't see anything, so I'm just trying to sneak a peek under that big old thing. And Janet's keeping us all straight. Here's what the station looked like to us as we're separating out again through our centerline camera out of our docking mechanism. And Steve getting a good look of what it looks like. And then as we do the fly around, you can see this is like a rear aspect of it. And then here we start phasing into nighttime, and it got just about that dark.
This is a picture of the shuttle from the ISS as we were leaving from underneath the station and moving out in front of it. We actually do an approach from below, fly all the way out in front of the station, and then we back in. And this is what it looked like as we approached from in front, and you can see this right here is a docking module on the International Space Station, and that's the target that we're trying to dock to. This is what it looked like from the flight deck as we're getting ready to dock. You can see the International Space Station coming down, and we're about 3 feet away, and this is what it looked like from one of our cameras. The orbiter's down here, and this is as we're getting ready to dock to the station. When we get within about 3 inches, we actually fire quite a few jets on the orbiter to make sure that we have good contact. And I was very relieved that the docking had gone well. That meant that we could carry on with the rest of the mission.
And at this point, later that same day, we were able to open the hatches, and there you see both of the commanders, Yuri Franco of the expedition crew and Mike Bloomfield of our crew. And we were the first faces these guys had seen in 4 months, so we got quite a welcome when we all entered into the U.S. laboratory. We got right to work. One of our jobs was transferring equipment. You can see I'm not only holding a bag, but I have another bag between my knees, which makes transferring in space a little bit more efficient than here on Earth. This view kind of gives you an idea, if you watch the lighting, of just how quickly a sunrise happens on orbit. And now a view in full daylight. You can see the station arm pulling the S0 truss up out of the shuttle payload bay. And here we are at the robotic workstation as we're doing that maneuver. You can see the 5 monitors there that are showing us 5 different camera views. And we used a number of different cameras to monitor the progress of S0 as we moved it around. This one is from the shuttle's robot arm elbow camera. And we also used the shuttle payload bay cameras, and this is one of the views that you're seeing here of S0 as we're moving it around and toward the install position. This view actually shows both robot arms, and you can see that the shuttle arm is in motion in this picture. Sometimes the camera view can be a little bit distracting. You're trying to monitor the arm in S0, but there's a beautiful view of the Red Sea and the Gulf of Aqaba and the Suez Canal and the Nile Delta behind it. And here we are moving S0 into the position where we're going to start the final install onto the zenith side of the laboratory. Over here on the right is the claw that's going to close around the capture bar and provide the mechanical attachment. And this is the camera view we were using for the final alignment. We're trying to get these alignment bars right down the center of these V guides right here. Dan Bursch was actually at the controls for that final install and did a great job. You can also see here at the robotics workstation a number of laptops, including one that shows us a bird's eye view of the station provided by the DUG program.
As you've heard, we did 4 spacewalks during the flight, and we'd like to take you through what a typical spacewalk would be like. This is the space station's airlock. I'm opening the hatch on the first spacewalk, and if the children will watch, I'll wave to you right here. We wear some pretty neat hardware out there. It's a 300-pound spacesuit. It's kind of its own little spaceship. And as you heard before, we actually have cameras on our heads as we do the spacewalks. It gives the folks inside an opportunity to follow us and the folks on the ground. Sometimes what we do during a spacewalk is manually move something like that. And again, Carl, Dan, Steve, and Ellen were inside using 2 robotic arms to work with us. And we're basically over their heads just outside the space station wall right there. Sometimes we actually carry large objects. This is an example of Rex holding a 400-pound object that on the ground would be very difficult to move. But in space, you can see you can even take one hand off. And to your left, you got a nice view of the shuttle here. So he's moving this 400-pound object very easily and going to place it down on the United States lab. This is a view from inside the space shuttle, Jerry and Mike helping conduct the spacewalk. And basically at this point, Rex is right over their head outside that window. Sometimes when we attach things to the space station, we actually got to work together. A lot of times we were apart. This is a view from Rex's helmet camera towards me right there in the back, helping him attach something to the space station. Suits are very comfortable to work in, and we really enjoyed it. Sometimes we do tasks like simply connecting electrical connectors. So here I am making an electrical connection. The gloves are much like working in ski mittens, though, so it makes it a little bit harder than doing it as if you were using your bare hands. We also make mechanical connections sometimes. So this is one of the struts you've heard us talk about. It'll be attached to S0, and it not only requires some pushing, but also some special tools sometimes.
And you'll see in the next view here a couple of those special tools. This is a power tool, much like you'd have in your home shop, except specially manufactured for use in zero gravity in a vacuum of space. And this is Lee attaching it to a torque multiplier that gives us 5 times multiplication factor to put the proper amount of load onto that bolt to properly attach it to the station. It's another great view of Lee as he was moving those keel fittings around to their stow location. Another one of his dismal times where he's out there having to watch the beautiful world go by. We also took parts of the outside of the laboratory off, and this is one of those MMOD shields that's being reinstalled by Steve and Rex after they'd rewired the connections for the station arm so that it will be able to operate off of the mobile transporter. As we told you, Steve Frick was the operator of the shuttle arm during the flight, and in particular on EVA-3, we used that arm to position Steve down there to do that rewiring of the panel you just saw. This is a helmet camera view from me on the last EVA, number 4. Great view of the underside of the station, particular down towards the Russian components. Great view of the blackness of space and the curvature of the Earth there. And that light that you see in my left hand is something I'm getting ready to install onto the station. Now this view is showing you a wide view of me looking around and enjoying this ride on the end of the arm. And this is the view I was seeing out of my helmet-mounted camera. You can see the orbiter down here. You can see this beam over here that I'm going to attach the light to and then take it off of the S0 and attach it back on the US node. Incredible views as Elwan and Dan and Carl were moving us around. This is the hardest part of an EVA, going back in at the end. Incredible experiences out there, and the time goes by very quickly, and it really is truly hard for a crew member to come back inside and have to no longer enjoy the views and the experience of being outside. So Steve in the foreground, and Rex over here with a camera, me in a suit on the one wall, and Lee coming in from the completion of our last spacewalk, and there's a high five between myself and Lee. Very satisfied feeling that everything went so well.
And this is a picture of the mobile transporter, the first railroad in space having its shakedown cruise. And this will provide the basis for the robot arm to actually extend and build the rest of the space station in future missions. But here it's getting its initial cruise. And we also have a lot of pictures coming up of various activities inside of the space station. Here we're having a barbecue banquet that we had with the space station crew members here in the shuttle, and you can see the Western motif with our bandanas. And the favorite item that we had was the s'mores that Mike made with candy bars and marshmallows and tortillas. Those were great. Here you have a picture of me doing a shampoo with a rinse-free soap and water from the galley, and no hair dryers there. You dry your head with a towel. And here Mike is using the exercise machine, the exercise bicycle. We also use this in preparation for our EVAs and to try to get some exercise. And here I am being the chef for the day, and I'm pulling the various food items out of the galley and distributing to the rest of the crew. And there you can see Mike working on some more tortillas. And finally, this is doing some housework. This is using a vacuum cleaner, and you'll see it looks kind of similar to what you'd have at home. And you use that to clean out the filters inside the equipment that traps there's no gravity to help clean the air. And here Steve is changing a LiO cartridge. These cartridges remove the carbon dioxide from the air. They have to be changed several times a day so that the air remains breathable. So he's letting us stay alive there on the shuttle. And we will take a few minutes to enjoy being in space. Here Jerry's enjoying microgravity. And these were, you'll see a somersault coming up. There you go, Rex doing a somersault. And these were very nice to show to our families when we had our private video conference with our families. And here's Steve Smith using a big ball of water. And you can see water's the size of a tennis ball. Has a big bubble inside it. You can see the amazing effects of surface tension. And there you can see a M&M got snagged by that big bubble. And finally, at the end of each day, we'd go to sleep, and you'd see us in the sleeping bag, covering our eyes and getting some rest.
Well, this is one of the sadder times of the mission also when we had to leave the space station. We'd done everything we'd come to do, and we were getting ready to undock and fly around. The last thing we do, obviously, is close the hatch. So we got the hatch closed, and then we sent everybody really to the flight deck, and we got ready to do the undock. On the flight deck, we had Mike and Ellen in the front handling all of the systems. I was in the back at the controls, and everyone else basically had a camera. And we all stayed real busy during the whole fly around. We had a lot of steps to go through before we managed to undock, and we were just getting ready here. We were pretty close within just a couple minutes of separating from the station. That panel there, I have the controls the jets of the shuttle. This is a view of the centerline camera that we use to maintain our alignment, and you can see right at the moment of separation we're starting to move away. And then here we have the view from inside the orbiter. This is really amazing because that part of the station that's moving away is only about 3 feet or so from our face looking out the window, so it really is an amazing sight to watch it slip away so close to you. We moved out in darkness and then got up to 450 feet and watched the sun come up. This is real-time view of the sun coming up on the station. We're looking from the orbiter and the sun's behind us, and as soon as the sun came up, we started to fly around. Once the sun does come up to where you can see it, though, it's blindingly bright in space, so we're all wearing sunglasses, but even with that, it was kind of hard to look that way. This was a nice view the station got for us of the space shuttle with an empty payload bay now that S0 was up on the space station. This is coming around the back side of the station. You can see S0 on the far side, and this is similar to the slide that we showed before the presentation. Flight deck got kind of crowded there, but everybody's working. You can see Rex there with the handheld laser. Steve is on the right and Jerry's on the left. Both have different cameras, and Mike just had to come up from the front to take a look since he has no windows up there that he can see the station with. And I was somewhere on the floor in that view. This was our last real view of the space station, right not long before the sun went down. You can see the S0 there and the beautiful golden arrays. just before the sun went down, and then we separated.
That was a shot that I took from the docking compartment. That was actually part of TI. And seeing Endeavour arrive was just a great feeling, knowing that it's your ride home.
This is us on the V-bar as we're approaching the final part of the approach. And if you look through the overhead windows, you can see the station as we slowly climb up or fall down the V-bar toward it.
And we were in all the windows available trying to get pictures and also getting some pictures from the SSRMS as well. We were very excited as STS-111 was coming forward to dock.
Yeah, my task there was to get the relative velocity, and I was using my eyes, my right eyes. That's why I'm closing one eye, because I was trying to look at the picture, and that's how we measure the velocity. You don't want to be too fast, but you don't want to be too slow.
After the two rings engage and 500,000 pounds of space vehicle is joined, we ring the rings together and create a seal. And after we check it for no leaks, we're able to go in and greet the other crew.
It was a very emotional moment, as you can tell. And of course, on the other end, this is what Carl and Dan were feeling.
Yeah, it's always great to see new faces on board, and especially knowing that it's your ride home. But we knew that you can see the stuff down by the feet there. There was some of the temp stowed equipment that we had. And we were also waiting for Franklin to come. He was the last one to come on board and finally get him. This was part of the handover ceremony. If y'all know, the first one got cut short a little bit, but this one we did complete and handed over the helm to Expedition 5.
On the fourth flight day, we pulled the MPLM out of the cargo bay. Then we smiled for the camera that was going by and commenced transfer operations.
And this one actually was also EVA preparations, part of the transfer. We had to get the suits, but the work on board continued, and that was one of the important things, is that we were able to multiplex many tasks together in order to accomplish what we needed to do.
But it's time to go EVA, and that's a long day. That starts with the pre-brief protocol, and here you see me with the oxygen mask.
This is Peggy and I working in EVA prep, and you would have seen the two astronauts, or Philippe and Franklin, in the actual crew lock, and here they are exiting for one of their EVAs.
This was the first order of business, basically on the end of the arm, to go and retrieve this grapple fixture. This is a device that allows the arm to lift things, and it will be relocated by us. You see me here on the arm being driven to the location over on the station where Pepe is already waiting for me to get it installed and for later use.
So on that first EVA, Franklin was on the arm, and I was doing all the workout, trying to go from one place to another one. And here is the view I had, going along the seal of the bay. So, but no time to look at the Earth, because it was about time to install the shields, and that's what you see here on that picture. Of course, you do, and you work day, and you work during the night. And things are slightly different. During the night pass, you get a little bit disoriented, and you get some feeling of being tired. Where during the day pass, you feel really great. Except at the end of the EVA, that's about 6 hours into the first EVA.
At this point, we are just about finished with with EVA 1, but there's still a few things to do. And that is, we have to get the MBS, which is still in the cargo bay, and we need to get it ready for later, as we walk back into the station, the robotics people, the arm that will take it off of the cargo bay and take it and put it on the station. In order to do that, we have to remove several blankets that are covering sensitive avionics that are have to be kept at a proper temperature. And all of that had to be done in a timely manner. We are fairly tired at this point, but we got it done.
And here we have the unberthing of the MBS. The MBS, of course, was then mated with the mobile transporter, the MT, on the S0 truss, and this will provide a platform so that the station robotic arm can move along the truss, and we can continue the superb construction and complete the power grid.
And once the MBS is on the station, then the job is to connect and deploy a few things. So we were able to also give signals to each other. We thought that nobody was seeing that, but actually, it's too bad. Anyway, we had to do a few pieces of work, right? For example, this big arm had to be moved out. It's about 400 or so pounds that you have to rotate, and then you have to tie it down with bolts, and then we finish that and move on to the EVA-3.
So that was my time to relax and be on the arm, and Franklin had the good workout. But actually I had some good workout too, because we had a lot of bolts to handle, and that was a critical moment, because here we take the end effector out of the arm, and we know that the clock is ticking now. Here I am taking the new joint in the bay, and you can tell by the color of the new joint, the old joint being slightly below. And it's about time to install that joint. And we started that EVA a little bit late for different reasons. So we basically had to catch up and work faster than we had done in the pool. And we ended up spending more than 7.5 hours outside. But all this Canadian hardware was very well designed to be changed out in space. So we did not really struggle too much with the hardware, except that it was broken in the first place. But
so you can see that the work involved, removing something, replacing with a new one, and then stowing the failed joint for bringing it back. You can see the new joint; it has a different color, and that was the end of our job. And of course, by then we were pretty tired, and we were asked to hurry up and come back in. And the station guys had the dinner ready for us.
It was a great pleasure for me to be able to operate, or actually help Valery operate the arm, and that was the arm working in 7 degrees of freedom, something we hadn't seen in several months.
Purple gloves. This is just some of the in-cabin activities you use to keep yourself going each day.
This is the bravest man I've ever seen in space. I'd never seen anybody shave quite so fast. One of the many laptop computers, and this is, we had Outlook email available. And I don't have a nickname of Taco for nothing. I'm making a breakfast Mexican burrito here, and I'm giving it to Paco to have for breakfast. And have.
Well, we tried to do a little science, fluid physics, which I was hoping to show my crewmates, except, and it was all going well until the pilots got involved.
This is a little bit of a tour. We're looking from the lab into the node, and things are starting to get, as we moved things out into the MPLM, it was good to see the layers disappear, and actually it was kind of fun when Taco asked for layers 4 and 5. And looking back into the lab here, and this was probably a time where we still had, actually that was a lot of the stowage that had come on board, and we were temp stowing it. Peggy had a good idea to temp stow things that she knew they were going to use right away. That area down at the bottom there is where the lab window was, and that used to be totally full with CTBs, and those bags right there were actually ones that came on board and were temp stowed as well. And now, and we still seem like we have a good bit of space, and now we'll enter into the shuttle world again. And it was took a bit getting used to living in such a large area and then coming into this.
Yes, I used to think the shuttle was big also, but with 9 refrigerators in the middeck, it isn't.
So the third EVA being done, it was time to relax, but not completely, because we still had to take our suitcase back into the bay, and that was great flying. You really want to make sure that everything is on the right side of the MPLM hatch before you close the hatch. I had the privilege to close that last ODS hatch and leave all our friends, and it was quite an emotional moment.
We're starting to separate now at about 0.15 feet per second, and this was a great pleasure for me to have the chance that Taco gave me to fly the vehicle away from the space station, and I knew as I flew that I was providing a wonderful opportunity for Carl and Dan and everyone else to look and see the space station in a beautiful way. And this is Taco making sure I'm flying the right direction. And Taco also gave me the best sun angle, so I had to wear something to protect the eyes a little bit. And this is just the view as we continue to move away.
Once again, just seeing the beautiful ship was absolutely incredible, and once again, thank you, Tommy Holloway, for providing us and giving us such a great ship up there. I would have never believed this could have happened even 6 years ago. It was truly hard to believe, but it's a great ship.
And Franklin and I, we would check that the everything would stay in place, the shields would not be floating away, and
Almost immediately, we begin the rendezvous process, which takes about 2 days of burns to approach the space station. I'm up there in the front, along with my core rendezvous team, Dave Wolf, who's a former ice cream salesman, Piers Sellers, the snail farmer, and Pam Melroy, who we call Tank Girl. Imagine how that would feel. We're all on the flight deck here. We all have a lot to do. It's very crowded. We're looking out 2 tiny windows as we travel along at 17,500 miles an hour, both vehicles traveling that speed. This picture is about 45 minutes before docking. You can see that we're closing very, very slowly to the space station. It's magnificent as you move in and look out those windows and look at the International Space Station hanging above Earth's atmosphere. It's brilliant. The color is very metallic and looks almost like molten metal. It's so bright in the bright rays of the sun. As we move in, things gradually get more and more exciting until we finally reach the space station, feel the thunk, and we dock. We know we've made it, a very critical event accomplished safely. It takes about an hour to pull these 2 pieces together and to pressurize the area in between and do all the checks, and then it's time to open the hatches. And what a treat it is to rendezvous and then open the hatch to living people. The crew had been up there about 4 months when we opened this hatch, and talking to other crews, they say that the most important thing for them is seeing new faces, and the second most important thing is food and the salsa we brought in a pecan pie, and the third thing is mail.
We didn't have a whole lot of time to meet and greet and say hello because we had to immediately get to work and transfer all of the Spacewalk equipment over to the station airlock, and we were busy flying back and forth to take piece parts of the spacesuit, put them together, put the tools on the spacesuits, and there was just a lot of work we had to do at the end of that flight day 3 after we docked. And of course, right away when we got up on the morning of flight day 4, the EVA guys got to work doing their pre-breathe and getting their exercise in for their spacewalk prep, and Peggy and I got to work on the S1 install. It was going to be a long day for us, and we got to work with the unberth. And it does take 2 people to fly that arm. There's a lot going on there. You got to manage the camera views. You have to do the actual flying, keep an eye on the procedures. There's comm between the ground, comm between the shuttle. Just a whole lot of work. We actually stopped a couple times and put the brakes on so we could fly over to the shuttle windows and look out the pilot's window and see what the 30,000-pound truss looked like at the end of the Canadarm, because the whole time we were only flying from camera views, and it was really beautiful to go look out the window and see what the truss looked like and out there hanging over the edge of the shuttle payload bay. Well, we worked through the procedures. There were some great procedures, and we got up and got the install done. And once the install wasn't done, we attached this truss with some bolts to the S0 truss and reconfigured for the EVA.
Meanwhile, back in the airlock, the EVA team are imprisoned still on their masks. When the pressure's down, we squirm into our spacesuits, and Pam and Fyodor put the final touches. You can see being gentle with us there. And there comes the moment to put on the helmets, and there's a final clunk, which means helmet on for the next 10 hours. And we're sealed in there good. Fyodor and Pam check out the lights, all the extra equipment, one last look over everything. And it's time to cram us into the airlock. But before that, we always indulge in a few pagan rites to appease the EVA gods. These little ceremonies, very, very important to ensure mission success if you do them right. Shove one guy in face first so that he's facing the hatch. Put in all the luggage. Shove the other guy in feet first. And there's just enough room to basically not scratch your nose because you can't. Close the hatch. And then it's another hour, and then you're ready to go out. Now, this is an exciting moment. Opening the hatch, it's a 240-mile drop, so don't let go. Squirm out, look around, grab a handrail, and then get to work. A lot of distractions. Here's a night pass. We've got thunderstorms going on below us. We're meant to be working, but sometimes it's just irresistible to sneak a peek at what's going on down there. Manhandling bits of equipment, moving them around, fighting with each other occasionally. No, not really. Then using power tools to bolt things in position. A lot of heavy work, particularly on EVA-1. It's good that we had our tools checked out in a thoroughly professional manner by EV1. And this is really the only way to get things done.
We make our way out at times to the very end of the truss, and we call this the end of the world, and it really feels like you're out there. That's a camera group that we installed. We worked together as a team, and that's the view back. You can see the shuttle inverted at the top, looking back through the truss. Remember that we have one tether on, and Pam is choreographing our activities the whole time with a detailed checklist from inside. Even though we're alone out there, it really feels with Sandy and Pam and the ground like you have real support. We ride the arm that Sandy is driving much of the time to do the detailed work. And if you happen to dare to look down, which I tried to avoid, tried to mainly focus on the station, you could get these incredible views, which if you let yourself, you can get kind of lost in. There's the empty payload bay. It used to have the truss inside, the laboratory module, the airlock that we have just come out of and we'll go back into after 8 or 9 hours. Total time, 7 hours outside. There's the truss that has been installed. We have many tools and bags of equipment to keep organized, and they're all on separate tethers, and it can be a challenge keeping that straight. This is an antenna that we installed, and you'll see how quickly it goes from day to night, at the same time going from plus 200 degrees to minus 200 degrees. Takes a little temperature adjustment. We're very tired after a little over 7 hours outside in this case. We come inside and we're just happy to be hung on the wall and let Pam and Fyodor do their magic, let us rest, and get us unsuited. You can see as the lower torso comes off this suit, that white garment has thousands of cooling water tubes that keep us air conditioned. We're looking forward to a good hearty meal after all that. This is the service module, a great place to congregate and eat. It's very homey. There's the table. And you'll see Sandy in her natural inverted perch. She had an amazingly quick adaptation to zero-G. Sergei filling from the rushing galley a food container, cans of food. The real purpose of this space station, of course, is to do science. And here Jeff is doing a physics experiment. And you can really see the different behavior and properties of materials where surface tension dominates. And this space station is truly an international laboratory bringing 17 countries together to ultimately do research in physics, material science, biology, plant biology in this case, where experiments to learn to grow plants for long duration so we can go to Mars and have more natural, fresh food. And it's fun for the scientists too, as Sandy demonstrates in the laboratory with her own experiment.
Well, let's take you on a little tour of the station as it is right now. That's a picture of Yuri Gagarin, the first human in space. This is the service module. Sergei is showing us his bedroom. That's actually his bedroom, that little closet area there. You see pictures of his family, you can see his personal gear, and that white bag against the wall is his sleeping bag. That's where he spends the night. The service module is a very homey place, as Dave said. You saw the pictures on the wall. It's got kind of green carpeting everywhere. It's sort of cozy and warm and a little bit dark. It feels like going to visit somebody's house. And this is the part of the house that you wouldn't ordinarily see. I think everybody has a place like this in their house. This is the closet of the space station. And you can see it's piled high with boxes. Most of that is actually food. As we get towards the end of the closet area, this is the FGB module. You'll actually see some towels on the wall. That's where the station crew does their daily sponge bath. And now as we go into the American segment of the space station, you can see that it feels very different than the Russian segment. It's very bright and airy, kind of metallic. It looks a lot more like an office space. And we'll take a quick peek here into the airlock, which is what you've seen a lot of earlier. That's where the spacewalks were conducted out of. And now we're going to float along a little bit further into what I think of as the crown jewel of the U.S. segment. This is the U.S. laboratory, very aptly named Destiny, because the destiny of the space station is to do science in space. And the walls are crammed with experiments. Peggy is actually doing a little bit of stowage here for some of the things that we brought over for her. But this laboratory is a magic place to do science, and it's a wonderful place to be in the station that has both a place to live and a place to work. Now we're going to take a crazy little jink and go over here into the space shuttle. And here we are on the mid-deck of the space shuttle, which is a combination kitchen, bathroom, bedroom, and living room for us. Jeff is making some dinner while Sandy is looking at her checklist to make sure we haven't left anything that we shouldn't have aboard the space station. Fyodor's taking a little coffee break there after having helped Sandy move some of these big bags back and forth between the shuttle and the station. And now we'll go up into the kind of the office area, the business end of the shuttle. It's upstairs. We call it the flight deck. You can see Piers here. He's working on the network. One of the first things we did when we got on orbit is actually set up a whole computer network up there to help support the things that we do. I'm also at the computer now getting ready for undocking. And just take a quick look around here. You can see how different the shuttle flight deck looks from the business end of the station. We have thousands of switches here. It looks a lot more like an airplane, and that is because it does have to become an airplane on entry. It was really an amazing experience to merge our two crews, the 9A crew with the expedition crew. I think the experience of living and working together in zero-G is just such a magic environment that it just made us feel very close. It made us feel like a family as we had all this incredible experience together. And as a result, it makes it hard to say goodbye.
Very good.
Yes, there's some tears shed, especially Peggy and Sandy. It was very hard to say goodbye. The commanders shaking hands one last time as we prepare to close the hatch and get ready for undocking. And here you see the shuttle backing away, and listen carefully.
Atlantis departing. Thank you, Peggy.
As Peggy performs what has become a tradition, there's a ship's bell aboard the station, and she rang us off in keeping with an old naval tradition. We used the thrusters of the shuttle to actually push ourselves away from the station. This looks probably a whole lot like the docking did. We all had different responsibilities during the undocking. We're all operating various pieces of equipment, but what we really wanted to do was all cram into the windows and look at the magical sight. It's a very emotional time to see the S1 truss and to fly around the station in a big arc, which is what we do. We could look at the station from all different angles. The reason why we do that is to take pictures. We're documenting the station as it exists in this configuration, both for future crews and also for maintenance. But this is a tremendous feeling to look at the S1 truss and think about the station as it will become in the future, as it's shown here, how much bigger it's going to get, and we're very proud of our small part in creating this huge international laboratory in space. It's a very, very wonderful feeling to back away and know that you've been a part of that.
Final portion of the rendezvous is done manually with computer control. We fly up in front of the space station about 420 feet, and then we fly in, attempting to be as smooth as possible and plume the station as little as possible to try to preserve its lifetime. See the rest of the crew with navigation sensors helping me, and Paco being the policeman with the checklist, making sure we accomplish everything. The system is a real testament to the engineers and folks who designed the vehicle. It's amazing to me that you can be flying this fast and be within a half an inch of where you need to be and within a hundredth of a foot per second of the desired target at contact. We have sped the video up here. It really is like watching grass go in a Moscow winter, but we pretty exciting day for us, and I hope an exciting day for Peggy.
Откроем! Commander Expedition 6 open gauge. This is very important things. Yes! Hey, привет! Hi guys, how you doing? Great job. Congratulations. Great job. Thank you. Very nice. Привет! Охуел?
First thing we need to do once we are finished slapping each other on the back is start bringing some of the stuff over. That first bag was what contains the seat liners that the new crew will use to put in the Soyuz, and then of course the EMUs for the spacewalks. Getting ready the night before the first spacewalk, we had to put some anti-fog in the helmets and configure all the tools. It's a pretty tedious job. It usually takes us well into the night. And the next morning it's time to get up early and hit the deck running.
The first day of docked operations, it was my job to lift the P1 truss out of the payload bay. As Peggy mentioned, I lifted up where she could reach it with the station arm and hand it off to her for the final installation. Ken Barasox assisted me, is a tremendous leader and a great asset to me. I was really thankful that he stayed on board our side for this day to help getting the P1 truss, which you see in our payload bay. Here we are moving the Canadian robotic arm. Mike L.A. is doing some pre-breathing, trying to purge the nitrogen from his joints in preparation for the spacewalk to go out and activate the P1 truss. We handed the payload off to Peggy, who's moving in, grappling on the station side. Joint operations very closely coordinated between the two crews as I held the payload and she moved in to grapple it, and then I released it. It's all hers, and then she'll move it in for the final position for installation on the space station. I'll move the arm away and use the camera on the end of the arm for a better view.
During all these arm ops, the guys in the airlock were also working pretty hard, getting ready. We had to be at a certain point before they could suit up, and so there were a lot of coordination between the guys in the airlock and us while we were attaching the P1 truss.
And this is a shot of Don and Paco inside. We're doing the prep. This is where the suit, including the person inside, weighs about 500 pounds, but you can just kind of guide, I'm being guided into the crew lock. And this is Don as he's closing the IV hatch, we call it. And just getting ready to start driving motorized bolt assemblies, MBAs, which actually bolt one truss to the other. And Don working on the robotic workstation as he's driving those bolts.
Once they were securely fastened to each other, we got to go outside, and there's really nothing that I could adequately say that would describe what this feels like. You see here the two pieces of truss. This is S0 down here and P1 up here, and the first thing we do is connect the two together electrically while John is reconfiguring the CETA cart, which you saw in a previous photo, so that we can take the launch locks off. Thanks to the wireless vision system, you can see up close some of the work that we do. It's not very complicated, but it's interesting.
I'm using a manual ratchet. About 50 foot-pounds are required to turn the bolt, and I'll turn those for one turn. So look like from inside of the shuttle looking out to P1. And then once I get those removed, I use the pistol grip tool, or PGT, and I let go, and my tether kind of pulls it out of the slot. And here I get a chance to go ahead and stow it. This is like herding cats also, getting it all stowed back into the bag. It looks a lot easier there than it was in flight, let me tell you.
On EVA2, the next thing we had to do was connect the two pieces of the truss together hydraulically, if you will. These are what we call fluid jumpers, and they carry ammonia, which is a cooling fluid used on the space station. And you'll see John is handing me the end of them, and then he will join me on the side of the truss. This is what happens when the sun goes down. This is real time. It doesn't take very long at all. Once we get them connected, we open the bail to open the valve to allow the two pieces to be connected together, and this is just sort of an overview of the two jumpers in place.
The launch restraints that were in place on P1 had to be removed once they were in flight, and this is Mike taking one of the keel pins off, and he's installing a bolt, and then once he had it in his hands, it was my job to translate the CETA cart down the rail, which was a fabulous experience, just by fingertips. You can, it's a huge mass, and just lightly pushing it down the rail. As Mike controls it, we have to take the keel pin, and now Mike will install it inside the truss. And this looks like from one of the cameras on the back of the payload bay.
Another ability we wanted to leave on the station was the ability to use this wireless vision system when the shuttle wasn't there. This is an antenna that's used to transmit the signal into the station. And we carried the antenna out of the airlock with us and then attached it to a stanchion, which you see here. This whole thing is about the size of a person. You'll see John here is on the very end of P1, and he's going to go over the edge, and this is what it looks like on the edge of the universe as far as I could tell. It's quite a view. I guarantee he's holding on strong with his right hand. As soon as the sun went down again, I grabbed that whole stanchion thing and handed it to John, and he's locating it here in the foot place where we're going to attach it using the pistol grip tool to attach it. And once it's all in place, we can take the cover off like chicken dinner.
Consider this the ride of my life. The robotic arm is coming into position right below the CETA cart, and it's my job to install a foot restraint onto the arm. And this is Mike removing the little, they're called wheel bogies, as I pull the CETA cart away from the rail. And then I had the opportunity to ride the robotic arm, courtesy of Don Pettit, all the way around underneath the space station to its fullest end. And it started off, and it started getting dark, and it was the blackest black I'd ever seen. And as we came back around the starboard side, the sun came up, and the most tremendously brilliant white light illuminating the station. And Mike guided us in, and here he's putting the last wheel bogey in place and locked it in.
Well, we knew we were going to have to come in side suit, so we took the opportunity to take a couple last pictures, and all good things must come to an end. But we went inside feeling that we hadn't lost anything, and later we confirmed everything because we double count for just to make sure. Getting out of the suit is a relief. It's like you coming home after a long day's work. You can see John and I look both a little whipped.
Transfer was a big job. During this time, we had to get large bags like the 5 mle bag floating up there, plus all the other hardware for EVA support and just for the Expedition 6 crew to have while in orbit. You can see lots of different things going on. Don's doing IFM while everything else is going on, so busy time. And here we're installing one of the payloads, actually exchanging. We had a new one brought up on the shuttle and putting it to the station, and then this one's going back home on the shuttle. PSTS. Protein crystal goes in. This is a tour starting on the flight deck of the shuttle. Heads down onto the middeck and around. You see all of the bags. This is obviously a little speeded up. You do a loop to go through the airlock and into the to the laboratory module, and you can see a lot of activities going on. You got to avoid people. That's actually one of the things that took a little longer for me to learn since I didn't have many people around. And you can see that the node was a little cluttered. The airlock there to the side, and then we continue on through the PMA and into the FGB. This is all Expedition 6 and 7's food, minus the stuff we ate. And heading into the PHO. Below us was the docking compartment, and here is the service module, which is the main area. We have the galley here and the toilet, and then at the end of that is the progress.
I hope that my crew, Don, Nikolai, and I will be able to work as well over the next however many months we end up living on station. Hopefully more than 4. And this concludes our ceremony for today. Thank you all for joining us.
Again, a change of command ceremony steeped in naval tradition. It's an honor to be part of ceremonies like this. I mentioned that another tradition is to put the flight patch up on board the vehicle. We have an awful lot of flights getting ready to go. Luckily, the station's getting bigger, though.
And here's Valeria installing our patch. Also in the node, we have a separate area for the expedition crews that have been up there. Number 5 looks good. Okay, here it is, the crews, everybody's saying goodbye, leaving Expedition 6, Don and Sox and Nikolai, who are still up there having a good time. Sox wrote me a note and said he successfully made Jell-O. Here's LA closing the hatch.
And here we are on the flight deck just before we undock, and things have to get back to work now. In other words, we have to concentrate on what we're doing because we're about to separate the shuttle from the space station. And this is a view out the window. That also must have been something naval. I'm not sure what that was. I found the undock and the flyaround on both flights, STS-111 and 113, to be a pretty emotional time, especially for the station crews, because it's the first time after they've lived there for 5 or 6 months to back away and look at the station and see how large it's grown. It's really a beautiful time to look at the station with the Earth in the background.
what we did is we put together some shots of training that we wanted to show you at the beginning. Beginning with, this is our traditional get together and do the crew photo at the beginning of training. We have T-38s that we use for spaceflight readiness training, acrobatics, formation instruments. We also have a virtual reality lab. Here, Jim Kelly is doing robotics training with Charlie and Wendy. Soichi's in one of our simulators doing training with the camera for the ET photo. Here he is in the neutral buoyancy lab for EVA training. Steve is doing emergency egress training in the launch and entry suit, and also some tile repair. We did some trips down to the Cape. You see Andy here doing some training on the inspection. He was our lead on the inspection. And Wendy was our lead on transfer. This is the MPLM and transfer training. Her and Charlie worked on that together during the flight. Charlie also worked on the inspection. Here they are practicing the robot arm inspection, and this is the Discovery's wing leading edge that we inspected during the mission. We also inspected in pre-flight. Well, we finally made it to July 26th. This is the Astrovan, the walk out of crew quarters, our strap-in. This is the mid-deck. Wendy's getting in her seat. You see Andy in the background, Charlie's in the foreground. And this is the moment we've been waiting for. After many, many years of work, we got Discovery. A lot of tears in people's eyes when we finally lift it off. We feel the tower going better than accelerating through 100 miles an hour.
Discovery, roll program.
Roger, roll, Discovery.
A view of the crew in the upper left, in the flight deck. We had a camera on our external tank. This is the LOX feed line. You see the ET over to the right, the booster on the left. The purpose of this camera was to watch any debris that might fall off. We've got the booster separation here. The cameras on the boosters actually follow them down to the ocean. And as you know, they're retrieved and reused. Back to the LOX feed line camera. First time we've flown a camera in this position, it worked quite well. Here's the roll to heads up. You can see the horizon in the background. That was about 6 minutes in the flight. Here we are about 8 minutes and 20 seconds. We have main engine cutoff. And shortly after that, you see the forward attach point. We're going to separate from the tank. The tank is going to fall away, and we will pitch around.
Houston Discovery, we have a good plus X maneuver.
We'll pitch around and photograph the tank.
Of course, once we were on orbit, we had to configure for on-orbit operations, so we opened the payload bay doors to expose the radiators, and then got about going to work. One of the important objectives of this flight, and one of the great successes, was, of course, the inspection of the wing leading edge and the TPS, and to do that, we used the boom that you saw a moment ago, which carried sensors and cameras on it that enables to record these views of the wing leading edge and the nose cap to ensure that those regions had not suffered any damage during the launch phase. We also used the cameras on the robotic arm to inspect the crew cabin of the orbiter, as you see here, passing the hatchway, which just a day before we'd crawled through to ingress on the launch pad. Because we had these systems on board, we were able to survey the entire exterior of the orbiter and verify that it had good integrity and would be safe for entry at the end of the mission.
We got to flight day 3, and this is an orbital maneuvering system burn that we're doing. You can see it's important to hang on down the mid-deck, having a little bit of fun. And we are going about the business of starting the rendezvous and docking with the International Space Station you see here. On the flight deck, I'm sitting up at the commander's seat, and Steve's up there with me taking some pictures. It gets pretty crowded upstairs when we're doing this. Charlie's helping out with checklists. Andy is photoing out the top window. Wendy's up there with the handheld laser, and Eileen's on the left flying us up to Space Station. Rendezvous and docking went very well. One of the things that we did on this flight that had never been done before was the rendezvous pitch-around maneuver. And this allowed the people aboard the station, John Phillips and Sergei Kriklyov, to take pictures of the orbiter. And so what Eileen's doing here is pitching us 360 degrees, and the station crew members are taking pictures of the exterior of the shuttle. And it was from these pictures that we were actually able to see the gap fillers that we'd remove later on in EVA-3. But as you can see, this is a shot never before seen from our flight, and it's just absolutely gorgeous. So this is what it looked like to the folks aboard the International Space Station. In parallel, this is what it looked like to us on board the space shuttle. This is, we're almost all the way through the maneuver now, coming back up to where the space station is going to be directly above us again. You can see it climbing above the tail as it went back up. From there, Eileen flew the twice orbital rate V-bar approach, and we got up to the front of the station. You can see sunset happening here, and we're actually going to dock with that white circle that's right in the middle of the screen. Here's the aft flight deck. If you look out the window directly above Eileen's head on the left there, you can actually see the International Space Station coming down into view. And the next photo is going to show you as we come down into a docking with the docking system, and we get to a mated configuration.
Probably the next anticipated moment on the flight is hatch opening, certainly for the space station crew. And as Vegas already mentioned, we were joining up with Sergei Krikalev, who just started his cumulative third year in orbit, and John Phillips. And there's Steve coming on board. There are a lot of traditions that are associated with the space station. One is the tradition that we borrow from the Navy, which is being gonged aboard with the ship's bell. Another tradition is right here. It's a Russian tradition, and when you have visitors, you share a piece of bread with them. There's Eileen taking a small slice of bread, and Charlie as well. We had been told by the station flight controllers that John and Sergei were really anticipating our arrival, and you know, as anybody who has house guests, they spend a lot of time cleaning up for us. And I want to tell you, as the person who is in charge of transfer, they did a tremendous job. We're taking you on a little bit of a space station tour right now. We just went through the node, which was nicely organized. We're going through PMA-1, which is the wall of CTBs. Now we're entering into the Russian segment. We're about to enter into the FGB. It's not always easy to translate in space, but you get to do fun things like this. So hold on to your seats as we rotate around. The FGB right now is a little bit of a storage area. You can see a lot of the transfer bags that are stored on the floor. But again, John and Sergei have done a great job organizing everything for us. Some areas are small, and so you have a traffic jam. Here's Charlie going high, and our cameraman is going low. And now you're into the service module, which is a great area to hang out. We shared every meal, dinner time that we could with the station crew. And it was a rare opportunity that we had just to hang around for a little bit. You see Sergei and Eileen enjoying a little bit of a break. Those moments were few and far between. And literally, as soon as we got on board the space station, it was time for us to start robotic operations. Vegas and I were the prime space station robotic arm operators. One of the first things we had to do was grapple the boom and hand it off to the shuttle arm, and you saw that maneuver right there. The next flight day, it was time for us to install the MPLM.
Meanwhile, down in the mid-deck, EVA folks are preparing for the first spacewalks. Yes, we are doing very hard, degassing the water bag, make sure you can feel the full volume of the water before the EVA. And make sure you put the pants on before we get out. And we can, you can see the big digital camera floating behind us and waving. That's a sign language in Japanese. Thank you. And Steve Ray is very happy before opening the door. This is a shot from mid-deck that I'm going outside. This is a view from outside that we make sure that we are starting the EVA. And the very first task was the demonstration of the on-orbit repair of the TPS. And we will check the tools one more time before we start the demonstration. The first demonstration was Stevie Ray did crack repair for the RCC. He used the Novax non-oxide adhesive experimental, and that's using a spatula. Steve doing Iron Chef in space. Tastes like peanut butter. And I'm using the tile repair we call the EWA, emittance wash applicator, using a Shugu type application to the damaged tile. And this shape we call it a PGT shape. I thought it was representing Japanese island. And both demonstrations were great. And we move on to the fun part of riding the arm, and let Steve Ray describe the ride on the arm.
Riding the arm up and seeing views like this was a great way to spend your first couple hours outside. We spent a little over 20 hours outside, and with the 3 EVAs, and it was just a real pleasure to work with Soichi-san. We're just spacewalk brothers after so many years of training together. This is the helmet cam view of climbing around on the space station. It's what it looks like. And when Soichi's out on the end of the arm carrying that big control moment gyro that he replaced, that's what he looked like. Spectacular view. Here it is being installed in its carrying location back in the payload bay. We brought up a new one and replaced the broken one on station. Soichi is checking his hair. Look at that big vortex pattern in the ground there. The things that you can see while you're doing an EVA are truly wonderful. It was time to, if you could look at that little spacewalking guy off the nose of the orbiter, that's EV2 working on moving up to the gap filler. Wendy was flying the arm with Vegas's help. Andy was supervising. We reached out and pulled out those gap fillers that were a little too far forward for us to be comfortable with. And the ground team put together a wonderful plan for us. It worked great. And we were pleased that the gap filler came right out. It's a little red RTV on it. That's the stuff that bonds it together, although not perfectly, obviously. And this is Soichi and I were sort of taking pictures of each other as we came back. And this is what the gap fillers really look like. They're sort of a cardboardy type substance.
Vegas and I got to do some repair work of our own, only indoors. And this was an RCC plug, reinforced carbon-carbon plug demo, where you would actually repair a hole in the leading edge. And this was a carbon silicon carbide produced by Thiokol. Here is John Phillips, Vegas, and Wendy putting in one of the payloads we brought up, which was the HRF rack. And John was very happy to get this because that meant he had a legitimate reason to be on station and do work. Now, the real brains behind transfer was Wendy, of course. We were basically her drones. And Wendy, and thanks to Cindy, did a fantastic job. And really the best way to transfer this cargo was basically form a conga line. And when you have several people, this is me tossing some bags which were tossed to me out, and this is going back in, going to Andy. Seems to be a little bit overloaded here. Looks like an old Lucy flick, but and then he's passing them off to Wendy, and of course Eileen was the water person that collected all the water. And here Sergey, Vegas, and I are wrestling with that famous ZSR rack, and we're trying to figure out just how does this thing go together and put it all away, and we actually did figure out how to do that and got it in place before we came home, and I'm happy. Wendy did a masterful job also on the arm, like you heard, and her and Vegas both flew the MPLM and put it back in the payload bay, and of course we had a great time visiting our friends and colleagues in space and eating with them and getting to sign the logbook on the International Space Station. Too bad we had to say goodbye. You notice Eileen is at the hatch, and she's making sure we really do get back on the vehicle and come home.
After saying goodbye, we had to go ahead and leave, and this is a view of Discovery undocking from the International Space Station. And one of the really fun parts of the mission, especially for me, flying this, was to do the what's called the undock and fly around. And Eileen and I have switched positions now, and I'm in the aft flight deck flying this, and Charlie's now got the handheld laser. And essentially our job is to fly around, take pictures, and look out the window. So this was several exciting views of the International Space Station. We actually do a complete circle around it, and we take a photographic survey to make sure that we know what the outside of the vehicle looks like. So, and beautiful views of the Earth in the background. And after that, we do a final burn to say goodbye to the space station and start working our way back home.
After we'd undocked and left the station, we had a down day, of course, and we had a wave-off day. That gave us a little time to relax and enjoy the environment. Here you see Steve and Soichi trying to figure out what to do with some EVA batteries, and Vegas expressing his frustration at never becoming a pro footballer. And we, of course, did some serious science, studying the rotation of bodies in free space. much to the consternation of the EVA instructors who own that tool. And Eileen is demonstrating the technique for climbing into the bag and going to sleep each night. Of course, on these flights, exercise is very important. And we kept our commander healthy and allowed her to exercise as necessary. While she was doing that, the rest of us were just pigging out at the galley and having a good time. Some of us got to play with our food, as you see Eileen and myself here, looking at the behavior of this liquid drop and spinning it up to see what would happen. Of course, Soichi watched all this. I don't think he was very impressed. I think at this point he just wished he had a pair of decent chopsticks to catch his food.
Payload bay doors are closing, and yes, it is time to come home. We got an extra day on orbit as we waited for the weather to get better in Florida. Here's Wendy suiting up in the middeck. But we didn't get to come home on the first try as the weather was bad in Florida. So on the second try, we did our entry into Edwards Air Force Base in Florida. And you get a look at the displays that we use on the flight deck. Our entry was at night, and in fact, we landed about 1 hour before sunrise at Edwards. This is the view looking back out the overhead windows. That's the plasma trail that forms above the shuttle. And you get another view from here. I don't get a chance to turn around and look at this, but our flight deckers in the back get a chance to do that, and I'm glad they filmed that for us. This is from the ground at Edwards. It's an infrared view, which is the heat that you can see that has built up on the outside of Discovery. You can see our nose, the RCC on the nose gets the hottest. This is the pre-flare. We're getting ready to do the landing. The gear is down. And we touched down on runway 22 at Edwards. After some post-landing checklists, we walked off the Astrovan and got a chance to walk around and look at the exterior of Discovery. And we found that it was in absolutely great shape. We got a chance to say hello to our families here who unfortunately were in Florida, but we did get to come back and see them the next day. And that's really a great end to a great flight.
We didn't have any time for luxury after taking a quick tour. Nick and Roman actually grappled the P5 truss, better known as Puny. They took it out of the bay and they positioned it on the forward left side of the shuttle. And as you see their arm in motion, above it you'll see the space station arm coming in. Sunny is now going in to grapple the P5. At one point, both arms were grappled. Once we had firm hold of it, we let go, and we had it.
As we said before, we did 4 spacewalks on this flight, and we had a lot of help getting into the hatch and getting ourselves ready. You can see Bill in LA there, and they'd actually close us off into the crew lock before each spacewalk, and then out we go on EVA-1, or the first spacewalk. The first spacewalk, the main objective was to install P5. You can see us coming out here. And then we go all the way out to the end of P4, approximately 100 or so feet. And then once we get out there, as you can see us all the way on the left, they move P5 up into position to be installed on P4. You have Joni and Sunny inside doing all the robotics work for this. And what they did was they brought it to about 20 centimeters, within about 20 centimeters of P4, and then let us take off the launch locks, and then actually moved it in closer. And you can see it now going into the soft dock mechanism. After that, you can see us actually, this is just before we installed it. We actually had to remove those launch locks. And then after we got it together, we tightened them down. You can see here how far out we are. We're actually inboard of where we put on P5. And then we had a little work to do outside on the other side of the truss. On the starboard side, we actually replaced the camera and the television camera group. Here you see Krister taking a picture of me with the camera. And then on the second spacewalk, we started our massive rewiring exercise. Like I said before, our main objective here was to actually take the space station off its temporary power system and move it to its permanent system. And basically, in layman's terms, what we were doing, we turned off half of the station, we unplugged it from P6, or the power truss that was vertical, and then plugged it into the main truss. Then we powered that side up, powered the other side down, and then we unplugged those two channels from P6, and then we plugged it into the main truss. And this was all orchestrated by Billy O. He was our intervehicular crew member. Basically, he was the brains, and we were just moving things around out there. You can see there's a lot of connectors, several dozen connectors that we had to do here. And also, to get to some of them, we actually had to move these two carts, which are the crew equipment translation aid carts, or the CETA carts. You can see right here is the CETA cart being held by Krister Fugelsang. And then he moves it from one side of the mobile base system to the other, and then connects the two CETA carts. Okay. And this is actually a picture of the guys inside that I'm taking here, of the three, and you can see that picture in our greatest hits somewhere else. And then EVA-3 was more of the same connector stuff, but we also had to move some service module debris panels. This is actually Sunny on the end of the arm coming into the back of the payload bay. I'm already there loosening the bolts so she can take the service module debris panels and put them on something we called a Christmas tree, which was actually a support structure for them. And then off she goes on the arm, and Nick is actually flying her up and around the lab and all the way to the side of the station where there was a receptacle for the Christmas tree to go. And you can see that in this part. Then I translate down there to help her out and throw the lock, and that was it.
On flight day 5, we had a little short schedule to retract solar array. It was supposed to go for an hour. Well, it turned out it was a multi-day task. And here's one of the examples of how it looked after the first day. Didn't look pretty, but at least there was enough inside that the Sarge could start to turn. On EVA-3, Sunny and Beamer was kind of told to go up and shake the arrays a little bit, and here you have a nice view. 44 pounds, yeah. It helped a little bit. The array got somewhat further in, but it was still not enough. And towards the end of the EVA-3, we got the news that we will have a new EVA-4. Everyone was happy on board except the commander for the shuttle was a little bit concerned. And to prepare for that EVA, we had to make our own tools. And here is the one which Beamer is using. It was taped with Captain to so we won't get a little electrical shock. And finally, after a lot of work by Beamer all over Ray, it's coming in.
Yes. Go on that can.
Final success.
For the undocking, it's just the reverse of a docking, as I found out. And you just make the station get smaller, and you just fly around. Krister took a few pictures. We had actually some tasks of pictures as we were flying around, and Krister and Beamer took care of those. And we got a half a lap fly around. So here you see us starting at the front, and we kind of go over the top. And then when we get around to the back side, we did a separation burn to set us up for our next task.
station. And you can see right after, actually before we launched and right after we launched, this is what the space station used to look like.
Exactly to the proper speed it up a little bit to kind of make things go, but you can see the awesomeness of the actual sequence. CJ flew an absolutely perfect, picture perfect rendezvous to the space station. And once we docked,
then once we finally got on orbit, one of the first things we had to do on flight day 3, this was a pretty busy day for everybody on board. Pat and Brew were responsible for taking the handoff, and Pat's going to take the truss, which was the heaviest element of the space station so far lifted to orbit, lift it out of the payload bay with the robotic arm on the shuttle, and then they're going to do a handoff between the shuttle arm and the station robotic arm. And here you see Brew and Sonny getting that in place and ready to do the handoff on flight day 3. And while they're doing that, Danny and I are heading to the airlock to get all of our equipment ready for the EVA, which we're going to do on the next day and start hooking all this stuff up. And here in the animation, you can see what Brew and Sonny were doing when they took the handoff with the station arm, is to put this thing in position. Once it was in place the next day, and here you see Clay in the background, Oleg on the right, and Brew in the middle. They're going to bring this thing into position where the automated bolting could take place. That was critical before Danny and I could go outside. Down in the lower left, you can see the KU antenna moving on board the space shuttle as they were moving that up. In the meantime, on flight day 4, Danny on the left, me on the right, with help from Sonny and Swanee, are getting ready to go out and do the first EVA on flight day 4. And here you see us coming out of the hatch of the airlock. And here's Danny coming out for his first spacewalk. Our job was to would be to connect the primary and secondary power cables and all the data cables, which bring the S3, S4 truss to life. Deploy the solar arrays, get them ready to deploy fully, deploy the panels the next day, and also release the radiator, which you see moving here. And the folks that got an award today, Janella Humans and Chris Schmidt, were instrumental in helping us get this, this device installed. And here you see us getting ready for the deploy, and as you can see, it's a full team effort. We've got everybody in the station there getting ready to deploy the arrays, as you see here. And it was a beautiful sight to see these things come out on flight day 5. We got both arrays are about 240 feet long, and of course all the help we had from folks on the ground. You see here, Kelly Beck was a flight director on that flight.
Once we had those deployed, it was time to retract the 2B array, and it was a real team effort also. You saw Sonny was running the computer, CJ was kind of running the show with the cameras and the microphone, and then we had JR and Danny, or excuse me, on this first one on EVA2, it was Swanee and myself were out there. This is some of the helmet video where we had to cut a leader off before we could fold this thing up, a spring that had broken loose. And here was the team inside, JR running the show as IV. We got a little bit more retracted on that second EVA than we thought. There we are at the end of that particular portion. I'm on the boom on the right, and Swanee's there on the mass canister. Anyway, we're going to finish that up on EVA 3, and there's JR on the arm, this time on the left, and Danny on the mass canister. And they spent several hours out there, and as you can see, their work was rewarded by the fact that we were able to completely retract that solar array. There's CJ making some of the final calls, and there's Sonny very happy with what we were able to accomplish. So that was a little bit of EVA 2 and 3. There were some other things that we did on that third EVA, and of course one of them was to repair the torn OMS blanket. We did a little practice inside. That was Danny practicing with a circle stapler. And then we put him on the shuttle arm with Brew and Swanee flying that, and we sent him out there. Here's some of his helmet video as he gets out in place and gets ready to fold that piece of blanket down. He did a great job. The first thing he did was push it in place, and then using that stapler that you saw him practicing with inside, did a great job of using that surgical stapler. There's Megan MacArthur and Kelly down in the control room, and Keith giving instructions and checking on things. Once he had it stapled, Danny used some pins to keep it in place on reentry. There was the team inside, CJ and Brew, and then myself as IV. While Danny was working on that, we had JR busy working on another piece of equipment just above the shuttle. So you could see he was just feet away from us outside, and he was installing an H2 vent. And this was the external portion of a system that was going to allow us to use an oxygen generator, which we'll need as we go to a crew of 6. Right after he had completed that, Clay and Sonny got to work inside in the lab and hooked up the rest of that portion internally so that the oxygen generator would work. We moved on to EVA-4 on flight day 10. That was Swanee doing some work. There we are both bringing in a keel pin as we clean the path that the MT or the mobile transporter would move along that path with a robotic arm. So we, at the end of EVA-4, had completed all the tasks that the crew had gone up to do, and it was time to come in. That was a great day. It was Father's Day, a Sunday afternoon, and we had accomplished the EVA mission that we had gone up to do, so we were very happy with that. Once we were inside, they would open the hatch, bring us in, and get us out of the suits. There's Swanee there on the left, and I'm on the right. The team was in there once again to get us out of the suits and greet us.
And then we undocked from the space station. Brew was at the controls for this part of the mission, and he flew the space shuttle straight out the corridor, actually hugging the bottom just a little bit because that's where the best place to fly is, and he backed us smoothly away. Meanwhile, we were taking pictures of the exterior of the space station as soon as the sun came up. Pat wanted to get a picture for the montages that we give all the folks that looks just like this, which is just like our patch. So Brew had to delay just a minute on the V-bar till the sun got just right so Pat could shoot the perfect picture. And it turned out well. It was worth the effort. So a few item entries we have to type into the shuttle computers with the jets. And here's the station looking nice and symmetrical, as I mentioned earlier. We even had it flying behind us for a while. I could see it back there clearly, so we did a little yaw manual maneuver of the shuttle to kick it across the tail so everybody could see it.
Charlie Hobauer getting ready to hand off S5 to start the next day's activities.
And you see that here in the video. The shuttle arm is grappled to the S5 truss and handing it over to the space station arm for installation on the next day with the EVA crew members outboard. And there you saw a picture of Charlie at the workstation, the robotic workstation, as he maneuvered the truss element to its position.
Although the S5 isn't very big, it's very, very important.
Absolutely.
Now, one of the really exciting parts of the mission was the coordination between the robotics and the spacewalk. So Rick and I are coming out of the airlock. We're translating, moving hand by hand out to the S5 area where Scorch has brought S5 up. Rick and I watched and monitored as Scorch brought the S5 into the soft capture position. You can see the pins dropping down. And then our first task was to drive the large bolts that hold S5 in place. So we got these foot restraints, we moved them into position, climbed into our foot restraints and drove those bolts. And it was pretty amazing actually watching S5 finally get attached to the station, realizing that we're expanding the station in length.
Of course, meanwhile, inside we had lots of transferred, about 5,000 pounds of cargo to bring aboard the space station and 4,000 pounds to bring back down to Earth, as well as a bunch of repairs on this old station. And there's a Scorch down there replacing one of the scratch panes on the window.
On this day of the flight, this is the day after the first EVA, we did what's called focus inspection. We had to move this boom from the payload bay of the orbiter using the space station's robot arm, then hand it off to the shuttle's robot arm, very complicated robotics task, and that's so we could go underneath the bottom of the space shuttle and take pictures of the spots of concern on the bottom of the vehicle. And here was the main damage area that we had.
On our second spacewalk, we went outside to replace one of the gyroscopes on board the space station. There are 4 gyroscopes that are used to stabilize the position. Rick is now removing the covering of the gyroscope that we replaced, and all of these are up on an area of the station in the center of the station called Z1. So Rick and I came out of the airlock and translated up hand over hand to Z1 to be able to uncover the CMG or the gyroscope and be able to replace it. We use drills essentially like a power tool on the ground. And we put a socket on there and we undid the various bolts that were restraining it. Rick then grabbed onto the CMG, which weighs about 600 pounds, and he did what we call a layback maneuver, kind of bending backwards at his waist to be able to lift the CMG out of the way, and then he handed it off to me and we restrained it temporarily, putting it on what's called a mutt ball stack mud. It's basically a tool to restrain it to the space station. I climbed onto the end of the robotic arm and Scorch did an outstanding job driving me over to the payload bay to get the new CMG. This one weighs about 1,200 pounds, and I spent a lot of time in the gym getting ready to be able to lift this thing out of the payload bay. But surprisingly enough, it was a lot easier than I anticipated, and Scorch moved us out of the payload bay. We had about 2 inches clearance from something called the nitrogen tank assembly that was right beside us on the stowage platform. That's a pretty spectacular view. You know, I'm glad somebody recorded this because all I saw was this big CMG that I was holding in my face. I didn't get to see the view. That's kind of what I was seeing, except I saw more of the gyroscope itself. But we brought the old one down to one of the work sites on the stowage platform on the space station. Rick came back from the payload bay. We kind of rendezvoused and put this new one here on the stowage platform. And then we essentially did the swap, taking the new one and replacing it with the old one. But to do that required us riding on the arm back and forth between all the various work sites, and Scorch drove me back up to pick up the old one that had failed, and Rick and I finally installed that and swapped it on the external stowage platform.
Well, there are several different ways of building the space station, and you've seen a couple examples. We put the truss on with robotics and spacewalking, and the gyroscope with robotics and spacewalking. This particular payload that we're taking out of the payload bay right now, with the shuttle arm and handing it off to the station arm, is a big stowage platform that we attached to the International Space Station. And that was all done robotically by handing it off from one arm to the other and then floating over to the International Space Station side and using the computers on board to send commands to latch the this platform to the International Space Station. And this platform holds a bunch of spare equipment for future uses on the International Space Station.
And this type of equipment will be really important in the future as we stop flying the space shuttle, to have a spot for external spares.
Next thing we got to do was education, talking with school children, this time to the Challenger Center just across the river in Arlington, Virginia.
And that was our way of honoring the Challenger crew from years ago.
On the third spacewalk, Clay Anderson and Rick went outside to do that when I was actually inside for that spacewalk. Clay did an absolutely outstanding job, and as you all know, he's still in space right now. He just celebrated his 100th day in space. But this was a spacewalk that was essentially focusing on communication equipment, and there's a great shot of Rick on the end of the arm. He had to transfer what's called an S-band antenna, and this is essentially part of the communication system for the space station, and we're moving things around just to allow us to move that large section in the center of the station called P6 out to the port side of the station. So Rick had to move some of the equipment from P6. Clay was also working to install what's called a BSP and transponder, again, 2 elements of the space station communication system. After they did that, we had to move these CETA carts, and the center of the space station is this long truss, and on that we have the equivalent of a railroad, basically, and these CETA carts allow us to put equipment on and move the equipment from one location to another on the station. But we needed to move these to the starboard side of the space station. There was a great shot of Clay up on the end of the arm, and during this whole process, at some point, Rick got a nick in his glove, and this is a shot of him looking down at his left glove, showing where the nick is. We terminated the EVA a little bit early, came inside, and then Clay and I took some photographs of the glove to be able to send it to the ground for analysis.
Because of the damage we had on the bottom of the vehicle, we were talking about maybe doing 5 spacewalks, perhaps the longest shuttle flight in the history of the shuttle program, to repair the damage. But all the analysis that was done on the ground determined that that wasn't necessary. And then we had Hurricane Dean, as you can see here, brewing in the Gulf, and we had to go from figuring out how to fly maybe the longest flight to now try to do everything we needed to do in much less time. Our last EVA, as you see here, and then close the hatch early and undock early and come home.
So for the fourth spacewalk, Clay and I had a chance to go outside and do that one. As Scott mentioned, we changed the choreography of the spacewalk literally the night before to shorten the spacewalk to enable us to get back in earlier, to close the hatch, to be able to undock. The large structure that you can see on the side of one of us is a stanchion to hold this boom on the space station. When I came out of the airlock, because of all the things that were in the airlock, the hand controller for my jetpack, if you will, deployed itself. And when we do a spacewalk, we always wear this thing, it's called a safer, that enables us to fly back to the space station if we inadvertently came off structure and the hand controller for mine kind of popped out. There's a great shot of us translating up to the work site. After we installed these stanchions, I went and worked on another communication antenna to lock it in place to enable us to move P6, and at the same time Clay was out working to retrieve an experiment that had been put outside in the space station, and he's now getting ready to bring this back inside. You can see him going to stick that on the end of his BRT, which is a tool that you use to grab onto things when you're out in space. After we finished that off, we went to the end of the lab and installed an EVA antenna system that allows us to take these kinds of images from our helmet camera. Tracy said, "Hey guys, look over your shoulder," and we looked down at Hurricane Dean. It was going by underneath us. Absolutely spectacular view. But we wrapped up the spacewalk after about 4 hours or so and got ready to come back inside, closing the thermal cover and the hatch to the space station's airlock, get ready to undock.
And with that, it was time to say our goodbyes. Here we are saying goodbye to Fyodor Yurchikhin, Oleg Kotov, and Clay Anderson.
Undocking is a pretty fun event for me. It's the one flying task I get to actually execute. If anyone would like the landing, that wasn't done by the pilot, it's done by the commander. I guess Bob Crippen and John Young back in the day didn't want to have a guy named a co-pilot, so they call him commander and pilot instead of pilot co-pilot, but I'm really the co-pilot. So Scott flies the docking, I get to fly the undocking, and this is a space station as we're separating away. And then of course Scott will do the landing. For our flight, again, it was pretty busy on undocking day. You basically wake up in the morning, get ready to punch off when the lighting is correct. You get everybody in position. You got 7 people cluttered on the flight deck. Everybody wants to take pictures, get a piece of the action, and somebody in there is supposed to actually safely separate from the station. That's supposed to be me. It was really a pleasant event. My first flight, I got to do a full flyaround. We actually shot a 3D IMAX video. For this one, we just separated out directly ahead of the station and then did what's called a separation burn, where we just do about a 3 foot per second acceleration to get away from the station. And after we did that, you're pretty much in a safe trajectory.
And we get up there and we start really fast. It's a very fast pace, barely attached to the station. There you go out in the airlock for a spacewalk while the guys outside start working with the arm. And so it's a very concentrated activity. A lot of people have to do their stuff according to a certain precise timeline. Here's Scott coming out for his first spacewalk, and here's Wheels attached to the arm carrying around a piece of equipment. Spacewalk was about 6 hours. Inside they were working with the arm. Their task was to essentially remove the node from the cargo bay of the shuttle and put it up on the temporary station on the node 1. This is of course the fast forward. We don't go that fast with the hardware. And so while all of this is happening, of course, the spacewalk is still ongoing, and in fact, at this point, they were concentrating on the P6, removing all the connection there, hydraulic connection, ammonia connection. They actually got sprayed. Scott got sprayed a little bit with ammonia, so we had to do a decontamination on the end of the spacewalk. And but it was pretty fast. I mean, a few minutes later, as soon as you attach a few hours later, as soon as you attach the node, there you go. We go inside, open it up, And we have a mask and goggles. Looks like we are robbing a bank, by the way. But it lasts only a couple of hours, clean up the node, and here we are working already on it.
EVA2, Scott and Dan came out the door, and there's Paolo quarterbacking from the flight deck of the shuttle, and the main mission of EVA2 was to outfit the outside of the node, the things that we couldn't carry on launch because it wouldn't fit. So they outfitted it with some handrails and some other pieces of equipment, and also they worked along the P6Z1 interface. As we disconnected the P6 from the top of the station, getting ready to move it on the follow-on EVA to the end of the port wing of the station. And so there's Steph and I at the robotics workstation while Scott, and again, this is sped up a little bit. We weren't this fast with the moving the P6. It's about 37,000 pounds, I think. And here you can see from Dan's helmet cam, looking inside the Sarge, this is where he found the FOD along the race ring there. And that kind of spooled us up for what we thought was going to be the first contingency EVA to try to take a look at that. Here's Scott and Dan attaching a grapple fixture on the outside of the node.
So we'd gotten P6 detached at that point, and it was time to attach it and put it in its final location at the far port end of the truss. But there are no cameras out there. So the robotics operators got P6 all lined up. And then we sent Scott and Wheels out there to essentially give a visual guidance to the operators, the robotics operators, to line the two up perfectly so that P6 would get attached to the station. And so once everything had been lined up using the robotic arm, the spacewalkers used their tools in order to actually fix the two of them together. So very thrilling moment actually to get P6 anchored at the end. You can see how far out they are. That's the shuttle way out there. It's tremendously far distance out at the end of that truss. We also delivered a new MBSU, main bus switching unit. And just as the EVA was wrapping up, we started to deploy the solar arrays. Now, we had a very high sun angle, and that gave us a little bit of difficulties, but we got the first solar array deployed without any difficulties. But P6 has one little bit of a cranky solar array that's given us trouble before, and you can see how bad the lighting was. At one point, it came out of some glare, and this is what we saw. We were all just completely horrified to see it. As I think I described it as a fur ball. So that kicked off some very intense activity for several days as we prepared to fix the solar array. And we had to actually construct the cufflinks, is what we called them. They're just basically load-bearing devices that you'll see Scott install onto the solar array. And it took a tremendous amount of effort for the ground and the crew to prepare for this spacewalk. And finally, it was time to go out the door.
Yeah, the morning of EVA4, music from Star Wars was sent up, so it really got us fired up for a very big day in space. My wrists are being covered here by 3 layers of Kapton tape for a little extra insulation and protection. One for my daughter Jenna, one for Luke, and one for my wife Gail, so that made me feel better. We got on the end of this enormous boom. It was the space station robotic arm plus the OBSS, so about a 90-foot boom that I'm perched on the end of here. And I just was treated to a God's eye view. This is much prettier in color, by the way. Take my word on it. But I could see the entire space station and just a phenomenal view on the way out. About 45 minutes out to the work site, like threading a needle, very, very difficult robotics to get me out there. And at the very end of the trajectory, lo and behold, I was able to see the damage, which we hadn't been able to really visualize all that clearly from the cockpit. And it turned out to be a snag in a guide wire and one of the hinge wires that had ripped apart 2 of the hinges. And so I had to cut the offending snag out and then install these cufflinks. The first one went in very nicely here, as you'll see. But as things progressed, I really wanted to have my buddy Wheels out there on the end of the arm with me because I needed to have an extra set of hands. You'll see in the next sequence here, there's some waving motion of the array. I needed to push, pull, and install the cufflink all at the same time. So I ended up using 3 tools at once here, and it worked out really nicely. That extra tool there we called the hockey stick. That was my my second best friend out there at the work site. Wheels is my best buddy, but we ended up putting in 5 cufflinks across the breadth of the solar array here, and you can actually see the full repair at this point. We stayed out for another half hour or so and monitored the full deployment of the array, and pleased to report that it's producing 100% power, taking loads on the space station, and I think it's really a triumph of the entire NASA team to be able to pull something like this off in just 72 hours of homework on the ground. A lot of sleepless nights for many, many people. At the end of the walk, we kind of cruised on back to the airlock, and it was really beautiful. I could just pull off with my fingertips and then coast for 20 or 30 feet. Just really a beautiful sensation. We were outside for 7 hours and 19 minutes this day.
And so at the end of EVA4, we had accomplished a lot.
Docking apparatus give us our initial push out away from the station, and we end up separating at a very stately rate of about 1 foot every 10 seconds. And Peggy rang us out, as is now the tradition. That's my one input at 30 feet to double the rate to 2 feet every 10 seconds. So a pretty spectacular view of the station as we were going out, and a curious lighting effect because there's no atmosphere or anything to dim the light. The station is very starkly lit. Again, we're missing a little bit of this because it's in black and white, but the station is very, very bright, very radiant, and then the earth tones beneath it are somewhat muted, so it almost looks like it's fake, like it's 2 pieces of film put together, but it is a beautiful thing. And then we bade farewell to the station as the sun set on it, and we did our final separation burn.
This is a view of the space station rising in the aft window of the flight deck during the rendezvous pitch maneuver. And we see Rex using the handheld laser to measure range and range rate as we're approaching the station at an incredible speed of about 1/10 of a foot per second. The video here shows Steve at the controls and the closure rate that we actually see. In a moment here, we'll speed this up, and you can see the docking systems coming together. Steve is controlling the orbiter to a tolerance of about 3 inches on these 2 huge vehicles traveling at 17,000 miles per hour. We get contact and capture of the space station, and congratulations on a job well done to the commander for just a great job of flying.
And here you see a picture when I opened the hatch for the first time on the first spacewalk, and right below me is the Swiss Alps. It was just a spectacular sight, and had a chance to look for a few seconds, and then it was going outside and get to work. Our first job on the first spacewalk was to prepare Columbus so that it could be pulled out of the payload bay and then attached to the space station. We used these high-tech power tools here to tighten and loosen bolts. And then here's a picture of Stan grabbing what's called the grapple fixture that we're going to put onto Columbus, and that'll allow the robot arm to grab Columbus and pull it out of the payload bay. So that's Stan upside down hanging onto the grapple fixture. And then here he is putting it onto Columbus, and gets it seated well, and then we use our power tools to bolt it on there real tight. Now to get access to that grapple fixture, we had to take some panels off of Columbus. And here you'll see Stan in the background putting one of those panels back on, while I'm working there in the foreground. And here you see a view from our helmet cameras. We have cameras on the top of our helmets, and here we're going over Cape Cod, you can see down there in the distance. And we also have helmet lights. You can see Hans here, as he's working outside at night. The helmet lights light up his workspace so we can continue working all the time we're going around the Earth. You also have sun visors and when it's sunny at daytime, and then you can put them up when your friends say, "Hey, look at me." And so get to wave to them at the end in the shuttle and take a picture. The second spacewalk, we were changing out a nitrogen tank that was empty on the space station. Here we're unwrapping the brand new one in the payload bay, and then I'm getting a nice ride with the new nitrogen tank, and they're going to drive me up to the space station so I can install it. And it's a great ride on the robot arm. They drive you really smoothly and take you right to where you need to go. And then here, Hans and I are installing it into the space station, nice and snug and tight. Now, while we're outside there, we don't have our checklist for each step that we're going to do, so Dex here is inside reading the checklist and telling us each step we need to do so we stay on the timeline and work it real well.
These reflections here are one of the reasons why we call Columbus our shiny module. And we have to do a lot of equipment out there, thermal protective covers, handrails. It took us EVA 2 and EVA 3 to do that. It's the favorite pastime of an EVAer once he has a couple seconds just to enjoy the view to Earth. And on EVA 3, we had external payloads to be attached to Columbus, and inside the robotic operators with the robotic arm outside helped us to do that. Here you see Stan carrying solar, a solar observatory to the starboard side of Columbus. And at the end, or in the middle of that EVA, he installed UTEF, European Technology Exposure Facility. Not only that he put it there and put UTEF, the second one, on, he also retrieved, together with Rex, of course, a gyroscope which has failed earlier on board, and we are bringing it back down to ground to fix it and reuse it. The end of the EVA, of course, is entering the airlock again and join our crew inside.
Stan had attached the grapple fixture earlier, which allowed me to come down and grapple Columbus. This was our major mission objective, and we're going to, working with Dan Tani and Leo Earhart's in the robotic workstation, we're able to move the Columbus module out of the payload bay. Now, this is sped up. It was really going very, very slowly, but we could look at monitors and look at the cameras and use that to maneuver this big module, this research laboratory, out of the bay and attach it to the space station. We're now moving it to the right of the shuttle, and we're configuring it. This is a view out of the aft window the guys were looking at as we were installing it. And now we're reconfiguring the arm to allow it to line up perfectly so we can pull it in to node 2. So that's a lot of reconfiguration. And now here we go. We're going into the node 2 to berth it. A little more motion. We're getting there. Beautiful views of the ground as we go by. One little more snug, and we're there. Columbus installed.
Once it's installed, we have inside, of course, also outfitting activities to do. And once we are in the lab, we have to remove a lot of launch locks. We see here Dan and Leo to install the panel, and Steve here to work on a handrail, or better say, footrail. Myself working now at an experiment level, removing launch locks of Biolabor.
It was a beautiful day, and we got some great views of Columbus with both external payloads and all the equipment attached. Space Station is just an absolutely incredible site, and it's very, very large. And it's just breathtaking to see it flying with the Earth in the background.
One of the things that happens on these really busy missions is right after docking, you get a quick briefing and have to get to work. Here is Box and I as we get ready to pull the platform that Dexter lived on until it was constructed and moved over to the space station. So we've headed through the hatch and got everything set it up and pressed right into our robotics activities. And here Box is accomplishing the final maneuver, driving this boat of an SLP over onto the POA.
Okay, Garrett and I are getting ready for the EVA the first night with our pre-breather. We're wearing our magic masks. That morning, I'm first out, get out, see the cameras, and I could actually see the guys, wave at them a bit. Our first up is to get down to the JLP and get the CBM covers off to allow the module to be put on the top of station and pressurized. And you can see Garrett here is in the process of disconnecting some power leads to the JLP. Did a great job there, and this is his first EVA, and he's a pro. After that, Dom and Takao were moving the JLP up. We're out in the SLP working on Mr. Dexter. We talked about giving him his hands, pulling our tools out. You can see down low in the right there as all the robotics action is going on. And then later, myself here on the arm with Garrett here taking some pictures. And then we're removing the OTCM and putting that in place on the arm, getting ready for the EVAs the next day with Mike. And I'll turn this over to robotics.
This is an exciting moment for Japan. We are using the Space Shuttle robotic arm to move the Japanese Space Station Module Kibo or JLP to Node 2. And we are getting closer to attach it. And on Friday 5.
This is a small step for one Japanese astronaut, but a giant entrance for Japan to a greater and newer space program.
I love Neil Armstrong very much. And once we open the hatch, we are working hard inside. Also, we are playing hard. I had a chance to throw a boomerang. It flew very well.
On flight day 6, Rick and I went outside for EVA 2, and our primary task that day was to attach the arms onto Mr. Dexter's body. So we had some free float tasks that we worked on initially. Here's Rick working with our pistol grip tool on a bolt there, and with a ratchet wrench here, making some attachments. And then here's Rick attaching the foot restraint to the arm so that he could be anchored in the arm and do some work from the arm. Next, we started to work together to get the first arm off of the pallet. We had a little trouble getting the connectors off there. Here's Rick using a pry bar, which we weren't planning to use. This is a normal way to use a pry bar. We finally got that bolt out. And then here's another use for a pry bar. We got this second, we call them expandable diameter fasteners. He got that arm off. Here he is pulling it out. And we're going to temporarily stow this one. He's giving me some hand signals. Going to temporarily stow this one on the side of the SLP, and then we'll go to work on the second one. The second arm, Rick is pulling the second arm out with the help of the robotics guys, box inside, driving him around. He hands that arm off to me. You can also see on this D handle real quickly some bandaging because it had some damage on it we had to repair. While I'm holding that arm, Rick is pulling the body up, rotating it up out of the pallet so that we can attach the arms. Another good job by the robotics guys inside. Here's Rick attaching one of the arms, putting that fastener in there. And this is what the Dexter looked like after we got the arms on.
This is the beginning of EVA 3, finishing up construction of the SPDM Dexter, I guess. And you can see one of the components that I've just passed off to Rick there. And we later attach those both onto Dexter. After this comes one of the first of many opportunities I had to look at myself in a mirror, I guess that's what they're accusing me of, while Rick pounded on me. This is Rick actually having an opportunity to take some closeout photos of the SPDM after we've completed the construction. Here's another opportunity for me to look at myself in a mirror as I climb across on the SLP platform. And while I was doing that, Rick started transferring some hardware from the shuttle over to the space station.
A good look of the Robo Geeks here as they're working inside. They've got me on the end of the swatter, so to speak, so I had to be nice. They're bringing me into the payload bay now so I can start the ORU, the orbital replacement unit changeouts. I started with the yaw joint, which is a yaw joint on a large piece of metal that's a spare in case it's needed for the arm. And then we started with some electronics boxes, DCSUs, moved those from the payload bay to the ESP or storage platform on the station. There's a nice picture of Bob up there on Columbus now, and you can see me flying right by him as he's working on the missies. I get some great shots of him. And it was a great day, and we're finishing up with Peggy in the airlock.
Here's a view of the completed Dexter before we attached it to the lab. Did a great job putting it together by the guys outside. Point.
Flight day 9, we did EVA 4. Here's Bob coming out of the hatch for that EVA. Primary task was the tile repair, but we had some work that we did initially. Bob went and swapped out an RPCM, and I worked on a electrical connector here that proved to be a little testy. we got to work. We set up our tower repair sample kit. We started to flow this goo that we call it, STA54. We tamped it down into all these samples, closed up the kit, and then played follow the leader, brachiating down the lab into the payload bay, where Bob very gingerly stowed the sample box into this stowage bin here. We had some cleanup tasks afterwards, so we kind of broke off and went our separate ways here. Here's me pulling off one of the socks on one of the hands of Dexter, and Bob got a chance to work on that connector that was not proving to come off for us. And then Bob didn't want to pass up one more opportunity to look in a mirror. So we finished up EVA-4, headed back inside.
So inside here, I'm giving a little bit of description about what I was doing in that mirror, I guess. And as we had a little bit of a break before pressing on into EVA-5, you can see Mike and I suiting up again for the 5th and final EVA. Mike's got the hatch open here, and one of the great opportunities to go out in a daylight pass and see the Earth right away before I come out behind him, and he helps me get some tools on myself before we head up to start putting in the system that would provide power to the OBSS, the sensor boom that was going to be left behind on the space station. Garrett and Box really helped us out a lot, making it go smoothly with passing off that boom to us when we were ready for it. You can see Mike and I working into positions both at the top of the truss, the top of the world, so to speak. And luckily, you can see that red light come on up there in the top, and there was at least much rejoicing on board the space station at that point. You can see after we've gotten it powered, we kind of had to feed the cable out during the robotics maneuver, and you can see the boom moving there as I feed that cable out. So Box was really patient with me as I fed that cable out. You can see the boom is almost in final position, and Box has passed it off to Mike and I and backed away, and we'll see Mike accomplish the final attach point of that boom to the space station, where it's now living and waiting for the 124 crew to come up and use it. After that, we pressed on to some additional tasks. Mike got to go over and work on one of the solar array joints, while I went over and worked on the recalcitrant Missy experiment with a hammer and got that installed before we pressed back into the airlock and completed the 5th and final EVA.
Our mission is drawing to close.
It takes about an hour and a half, so we actually experience a sunrise and a sunset during that period of time, so you'll see both daylight and nighttime views of the space station. This is a breathtaking view of the backdrop of the Earth below. And then at night, we're starting to get further away after a separation burn.
And as we get closer, we see our goal, their space station, and she's beautiful. At sunrise there coming up, first time we see all the beautiful colors. Here's Karen keeping us in line. And we show up underneath space station. She's huge. We're about 600 feet below her. And Mark leans over to me and he says the words that any person on an airplane doesn't want to hear.
Initiating RPM, 3, 2, 1, mark.
He says, watch this. And he pulls back on the stick and says, I'm going to do a loop. Okay. He'd get fired if he did that without telling anybody. So this is our little maneuver to look at the belly of the heat shield of Discovery. And it turned out she was in perfect condition, so we were happy for our ride home. We had a lot of work to go. And here comes the rest of Rendezvous. We're getting in here at about 20 feet, a couple of minutes to docking. And we have gone, again, about 1 million miles down to a 3-inch tolerance. And here's Mark finishing up the rendezvous, precisely guiding the docking port right in the heart.
0.09.
2 inches.
Capture light.
And there was much rejoicing.
And Houston and station capture confirmed.
All right.
All right.
I'll get on with Aki.
The next day, they get us suited up, shove us in the airlock, close the hatch, and a little while later, we're heading outside to get started. I think some of my first words to Ron were, whatever you do, don't look down. The first spacewalk, a big part of it was preparing the Japanese laboratory to be installed on the space station. You could see a little bit of us moving around out there very carefully, going from handrail to handrail. If you don't look down, it's a whole lot like just in training. Ron taking a peek in the back windows of the orbiter. Everybody looks so warm and cozy inside. While we're out here, the temperatures are plus and minus 200 degrees, and you're dealing with the lights going out about every 45 minutes. We pulled the covers off of the Japanese lab and got it all ready for the installation. You'll see some of that in a few minutes. On the second spacewalk, we're hauling a couple of great big cameras down to the outside end of the Japanese laboratory here. We got those cameras installed and then commenced pulling off a bunch of covers that were on that Japanese robot arm. These covers were a special joy to us as we pulled all of those off and tried to get them stuffed in bags to bring them inside. And this is some audio that we did not include in the video.
Okay, this is getting ready to start on our third spacewalk. This is just a view of the solar rotary joint that Mike was inspecting, and this is us putting the foot restraint onto the end of the robotic arm. Our main objective on the third spacewalk was to basically replace this big nitrogen tank that you see me holding there. It's about 550 pounds, and we temp stowed it way out on the truss here, as you see that, and then we grabbed the new one that was brought up on an earlier flight and brought it back and installed it. And so this is what we call the windshield wiper maneuver, with me on the end of the arm sweeping a big arc over the top of the station. So right now, the station's about 100 feet below me with the Earth 220 miles below, and it was just an absolutely spectacular view that you could see from my helmet camera right here. Probably about 270 degrees, seeing the whole horizon out there, and really just unbelievable view, seeing the blue planet just hanging in the blackness of space was just an incredible sight. This is installing the nitrogen tank back onto the truss. And you can see a view down the truss there as we do that. Meanwhile, Mike is back inspecting the port side of the arrays. Again, taking some samples and just doing an inspection, making sure everything's okay out there. Then the last part, or one of the last parts of the third spacewalk was to install this TV camera way out on the end of the truss that we retrieved on the second spacewalk. Mike and I repaired it inside and then brought it back out. And then here's Mike with an Aggie salute, which signals the end of our spacewalks. We are on our way back in now, just saying goodbye to the spectacular view as we come back in. Here I'm closing the thermal cover, and there's our welcoming committee.
One of the first things we had to do was pick up the inspection boom that STS-123 left behind. We couldn't take it with us because of the size of the Japanese module in our payload bay. So we picked that up, and one of the main goals, of course, of our mission was to install the Japanese lab. And here you see Aki is gently pulling it out of the payload bay. And then we started a very, very slow maneuver of this gigantic module. It's the biggest that's on station so far at over 32,000 pounds. The maneuver, obviously, with such a big mass, had to go quite slow. It was about an hour of maneuver, but it was some great views while we did that. And of course, as we attached it onto the space station, it was a great day for the people in Japan. Another thing we needed to do with the robotic arm was move the logistics module. This is another piece that STS-123 brought up, and they had it temp stowed. So we slowly guided it over to its final resting position on top of the Japanese laboratory. We also had the opportunity to work on the new arm that is actually at the end of the Japanese lab. Aki and I worked together to check it out and get it ready for folks to use in the future.
After we got the Japanese module installed, we opened the hatch, and here's us putting a sign. It's a Japanese curtain. It just said, "Eat more chicken." And then after Karen and I checked out the air inside, everyone came inside, and you know, especially Garrett enjoyed the moment, showing off all his skills that he learned through his expedition. After having some time of fun, we had to get back to work. We transferred 8 racks. These racks are like 500 pounds each. And this is a sign where the technicians on the ground put at the hatch for us. And we saw the Japanese module grow each day. It was empty, and then it was full of racks. And in the stowage module, it's empty now. And also in the Japanese module, we had 2 windows, which we looked outside every time that we had some free time. The view out there was magnificent.
Houston and station from Discovery, physical separation.
And now it's time to detach from station and head home.
You guys ready for a little theme music?
Yeah.
And it's this music is actually for real. Garrett pulled this out and started rolling this in the cockpit, and it was a true surreal moment. It was a point in the mission where a lot of the stress of all the EVAs and the robotics and the assembly and all the tasks that we had trained for a long time, it was all behind us, and we could actually really, really enjoy the moment. That was us coming up on the western coast of South America, and now here we are over the Amazon jungle.
This is great music. Nice choice.
Thanks. And then there we are alone again.
A quick little cartoon of us installing the S6 truss and then unfolding those solar arrays.
Next morning on Flight Day 4, we did get to work. Here's Sandy and I moving that 16-pound truss out of the payload bay using the space station robotic arm, with Brew helping us out from the flight deck. And here you see a picture of the truss coming out of the payload bay, and we're going to flip it around and get it in a position to hand it off to the space shuttle arm driven here by Tony and Joe, who are then going to move it to another position. And in the meantime, while they're grappling the truss, or while they're moving the truss, the ground is going to move the railroad cart that the station arm rides on, so we can grab it back from them and put it to bed for the night. Meanwhile, the EVA guys have spent the night in the airlock, and Tony and Mike are getting ready to, well, they've got them suited up and they're going through all their checks. This is the next morning, and Koichi and I are moving the truss with the space station arm to its near its final position, while Tony and Mike are keeping working, getting Ricky and Swanee out the door on the first of our 3 EVAs. This is a view of the space station airlock hatch from outside as they open the thermal cover. In the second view, Swanee's outside and Ricky's in view through the hatch, and he's coming on out. And then as soon as they got out, they scampered up to the S5 truss. S5 is where we're going to install the S6 truss. And here we have Swanee coming up on S5, and in the top of the picture you see the claw, which is going to grab the S6 truss. And here's the gap between the 2 trusses as we're driving it in. There's Koichi and I in the inset driving it in with a robot arm. And once the claw had grappled it and dragged it in, the EVA guys still had a lot of work to do to configure the truss. They've folded out the blanket boxes and what's called the beta gimbal assembly. In other words, all the support structure for the truss, for the solar blankets themselves. And now the ground has commanded a deployment of the photovoltaic radiator that keeps all the electronics cold. Then the EVA guys were just about done. The radiator's deployed, and the next scene you'll see us You'll see a happy joint EVA and robotics crowd after a long but successful day. Then the next day, flight day 6, was a moment of high drama as we deployed the solar arrays, some of which had been in the box for nearly 8 years. We had a beautiful plan that was put together by the Falcon team, and they did a lot of the commanding, and then the crew did some as well. You can see the whole crew here on the Space Station Robotics Workstation area. Every one of us had a job to do, and the plan went really well. You see me there with my finger on the abort button, but I never had to push it. We had a great plan. It went smoothly, and we brought the station to full power.
Well, besides the S6 and solar array tasks, the EVA crew members had other tasks to complete. Here, Joe's working on pulling that UCAS up into the very robust detent position. And here's from my helmet cam looking out. You can see Joe working away on the diagonal brace beam. And again, here I am on the UCAS working on tying it down. And Joe got to take a ride. We moved the seated cart from the port side to the starboard side. And Koichi's driving this. It's like a fast Japanese sports car here. But Joe says he couldn't feel a thing the whole time. And here, Ricky's working on his skills to be a mechanic. He's lubing the latching end effector of the station robotic arm. And you can see the fruits of his labor there as the snares open and close. And then our EV tasks were done, and it was time to come on in.
And it was quite an impressive view, and there was a lot of fighting for window space up there. And you see the shuttle shadow going across the station there on the left. And as Tony did a great job flying us around, we start going out to about 600 feet. And Kwachi did a good job having everything lined up. But at this point, things are starting to get back to normal and putting these solar array wings back to work. It was quite a spectacular view. I know I wasn't the only one thinking, hey, can we do another spin around the block and maybe do this one more time?
First thing first, we had to install the exposed facility, which of course was way too long for us to talk about, so we called it the JEF. But really what it is, it's a exposed facility, it's a port. In order to get it on station, we had to pick it up with one arm, pass it to the other, and then pick it up with the same arm that was used to pick it out of the cargo bay. Quite a complicated robotic ballet, which was devised by our almighty flight controllers and planners on the ground. This is extremely sped up. We don't operate big pieces this fast. So when it was properly aligned, and this was practiced on the ground several times, Doug Hurley and Koichi Wakata aligned it up and installed it, and here it was in its final position. It's still up there. Well, we had to do this kind of handoff of pieces of our cargo bay 3 more times in the mission. So we picked up a piece, we handed it off to the other arm and installed it on station. Here comes the jelly, which carried 3 Japanese payload that we would then use the Japanese arm, first time we would use it in an operational manner, to pick up those payloads that would be installed on the exposed facility to do science in the vacuum and space for months to come. We had 3 of those payloads, so we had teams. Each payload was done by a different team of robotic operator, and you see them right here, and installed one at a time over the course of 1 day onto the exposed facility. And here's the jelly empty. It then got picked up yet again by the big arm, given to the shuttle arm, and put back in the cargo bay to come back home with us.
So in order to pull off 5 EVAs, we had a 4-people team: Tim, Dave, Tom, and myself. You can see on to make a flight day 4 EVA happen, which is a day after undock, there's a lot of equipment that needs to be transferred immediately, and that earlier picture was Dave doing just that. Getting the folks in the crew lock is no small task. They're 2 big, cumbersome guys in the suits, plus all the umbilicals, and routing those umbilicals so we don't get all tangled up took us a few learning curves, but we got it. A lot of integrated robotics on this mission, which is very communications intensive, which we practiced for quite extensively on the ground. You can see Doug and Julie would drive Dave around on the arm, this here on EVA-2, as he's going into position to grab some of the large ORUs that will place to their storage platform on the station. Down here you can see Tom through Dave's helmet camera as Tom's getting in alignment to help provide clearance views. This is the S-GAN antenna, which gave Dave nightmares prior to launch as he worried about that banging that antenna. Dave likes to say that he's happy he lives in the future where the antenna is in good shape, not the other future. Here's Dave installing the pump module. This is an interesting piece of equipment because the module itself is larger than the platform that it sits on, so it's difficult to see the alignment as he puts it in there, and it took a lot of coordination between Tom and Dave in order to pull that off. The next phase of the EVAs got into batteries, and here you can see 2 of us working with the batteries. They're about 5 feet by 5 feet by 2 feet or so and weigh several hundred pounds. And they actually move fairly well and stable once you get them out of their attachment spots, but they did require a significant amount of force. That force, which you can see, makes the arm oscillate, and that's what gave Julie and Doug their nightmares. So we would do a technique called a shepherding or handing it back and forth. And this is MLI. We heard earlier a group gave an award for that, and I'm sorry to those folks that I had to throw your MLI overboard. This is a view out the Japanese window as on EVA-5 when Tom and I were out there working on some cameras to install, as well as prepare some handrails for later use. This is a view of the small camera that we installed. And you can see the safety tethers that we use strung along, and that's where you have to pay particular attention to making sure those are straight and don't get tangled.
You can see the shadow of Endeavour there in the solar rays. Obviously slightly sped up. Not a lot, though. I flew it pretty fast. There's a view from Space Station of us doing our fly around.
It was incredible to see everybody there and work together.
So after docking, we had to get to work on the robotics. All the kids in here that play video games to be great robotics operators. We had the logistic carriers in the payload bay. We had to get them out with the shuttle arm and actually grab onto the carrier with the big arm, the station arm. So that's ELC-1. That's the first one that Butch installed on the Nader port side of the truss. And then Randy and here's Scorch and I, were actually taking out ELC-2. And that was the second logistics carrier. It was about 14 tons of payload that we're going to add to the space station. So here we're moving the arm. It's like a big video game, both on the shuttle and the station side. That's the target pin. We go down and grapple that, and there's the ELC-2, or the Logistics Carrier 2, coming out of the bay. Lots of hardware for the station to help us keep it going through 2015. So we're getting it ready to grapple from the shuttle side, from the station side. Here's the SSR mess with the big arm grappling. Steve, Frank DeWin, and Jeff were actually grappling this. And then Jeff and I actually installed this on the starboard side of the truss.
You know, in space, you got to have somebody help you put your pants on, so we had that help there. Come out on EVA-1, and we were off to the races. Beautiful sight once we got out there. Picture of me down here in the payload bay from the aft camera, and there's an important message I sent to my Army brethren. We had this spare S-band antenna. That was our first task. Bobby was flying over on the arm. There's a view from his helmet camera down into the payload bay, and I was turning some bolts to loosen that antenna. And here's Leland and Butch driving him around on the arm. And I handed this antenna off to Bobby, and then he took it away. And we went over to install this thing on the space station. So we get this thing installed. There's a beautiful reflection of Bobby in one of the radiators out there. And here's Comrade hard at work as our IV crew member.
So I was the lucky one that got to do surgery on the arm, as you can see here, making use of some surgical skills. Basically, we were lubing the end effectors that were on the station, and I was the lucky one to get to ride on the arm and get some fantastic views. Moving over now to the Japanese segment of the station, where there's also a robotic arm, and repeating the maintenance procedure on the Japanese arm. Here's a picture of Leland and Butch.
And here we are getting ready for EVA-2. You can see us halfway suited up at this point. Always needing help from our friends to get our pants on, as Mike mentioned. Heading outside, our big tasks on this one to relocate some antennas. Here's one of the antennas was on the very top part of the station. You can see us silhouetted against the blackness of space as we're installing this antenna and putting the little feelers that are up on top of the antenna portion out in its new location. Here's a view from Mike's helmet cam while we're up there. And then you can see on the top right of the screen the commander of Atlantis waving in the window. And then you hear us talk about spacewalks, because as you can see, there's no feet involved. This is all crawling with your hands. So you're walking with your hands for about 6 hours, and this is the route we would take back to the airlock when we're either finished from the EVA or going back to pick up additional spare parts. So then once you're back inside, you know, as much effort as it took to get in, well, you don't have gravity to help pull you out of, or help you fall out of the suit. So as you can see, Butch is standing on Mike's thighs, holding the arms up, and trying to push him out as Mike wheels his way out of the suit. It's a little more challenging, but just like everything with spaceflight, you can use a little help from your friends. Almost like birthing a baby calf.
Wish I had a microphone.
There's some of our robotics folks helping out with those EVAs. Then EVA-3 is coming up here. Mike took off the training wheels, and Bobby and I got to go out together on this one, closing the thermal cover that goes into the crew lock. This one, our main big task was to take the oxygen tank that was on the cargo platform that we took out of the shuttle payload bay, that you can see on the bottom right of the picture there, and attach it to the airlock. So Bobby and I, our job was to release it from the cargo platform. And you can see Bobby in the helmet cam video here. He's putting his camera away. I'm coming up on the right side of the view. And what we'll do is we'll take this platform and turn it 90 degrees so that the grapple fixture is oriented so Butch and Leland can grab it with the big space station arm you see on the upper part of the picture. Here comes the rotation now. Only about 1,500 pounds of tank, which fortunately doesn't weigh anything on orbit. It's just a little massive, so you gotta move it kind of slow. Then our robotic studs grab it with the arm and fly it away to the airlock while we scurry back like little ants back to the airlock to go ahead and attach it. We were fortunate enough with our hardware on orbit and the fact that we had a great train team here on the ground. We got about 6 hours of get-ahead tasks complete. So it is almost like 4 EVAs worth of tasks done in 3 EVAs. We're very fortunate with everything that worked. And here's the happy guys at the end of it.
Mike and Scorch up front helping us out. The beauty of station, there's a little panoramic down below as we execute our fly around a little sped up. And the station is just absolutely beautiful with the sparkling silver and the contrast of the gold solar arrays, the detail. You look at this and you think the literally hundreds of thousands of man hours put into on the ground preparing this vehicle to go up to space piece by piece. And a beautiful, beautiful sight it is. But eventually we do have to say so long and affect that burn to leave and start heading back.
Our big task that we had to do was robotic operations. Kay and I used the space station arm to remove Node 3 and the cupola, which were attached together from the shuttle payload bay, and we moved them around and attached them to the space station. That maneuver right there took about 2.5 hours in space. And here you can see us grabbing it in the shuttle payload bay and pulling it out. We moved it to the Node 1 port side, which is the left side of the space station, and about the middle area there. The views that we have are all from video cameras. When we did this, we did not have any windows to look out. And there you can see the Node 3 in the final attachment phase. After a few days, we took cupola, moved it off the end of Node 3, and attached it to the bottom of Node 3, or the nadir Earth-facing side. And in these views, you can see how crowded it is outside. There's several modules and different robotic arms sticking out, so it's a busy environment to do robotics in. We had one more large operation. Bob and Nick used the robotic arm again to move a small station module called PMA-3, and they took that from the front top of the station and moved it back to where the cupola had launched from the side of Node 3. And out the cupola window, you had this view for the first time of robotic operation. We were taking the shuttle sensor boom and putting it in the undock location.
We had the luxury, as we prepared for our upcoming spacewalks, of a day and a half to prepare tools and for Nick and I to get things ready before going into our camp-out procedures in the station airlock. After spending the night, we came out with our special underwear and our special air to get ready for the first day's spacewalk. You can see Nick and I both getting suited up here with the help of George. You saw Jeff help us get into our suits a little bit earlier, and you can see TJ there helping us get into the airlock before going out for the first spacewalk. Here Nick and I are closing up the thermal cover on the airlock before heading out to Node 3 in the shuttle payload bay to start removing some of the hardware that launched, protective hardware that had to be removed before we could mount Node 3 to the space station. What you can see there is the sealing surface that keeps the atmosphere of the space station inside the space station, and we're really happy there was a nice protective seal on there.
We also had to unplug Node 3 from the payload bay where it was getting its power. There's the extension cable. It's a little hard to manage in weightlessness, as you can see. And in this next view, you'll see Bob and I heading back to the space station. Here's Bob translating along Node 3 towards the front of the shuttle. And if you look way up in the back, you can just see me translating up Node 2 towards the airlock. Our air traffic controller inside was Steve Robinson, did a wonderful job talking to us and keeping us on track on the timeline of the EVA. And here we are plugging Node 3 into its new home on the port side of Node 1. You can see the cables behaving like snakes.
At the end of EVA 1, Nick mentioned that we hooked up power to Node 3 from the space station. For EVA 2, what we did after closing this thermal cover again was to hook up the cooling system for Node 3. Basically, we took high-pressure ammonia lines and mounted them from the U.S. laboratory over to Node 3 They had to be encased in some special insulation, and all this hardware was quite a bit bigger than Nick and I were. These ammonia lines were actually really problematic, and kudos to the team that got them together and actually got them on board our flight so we could install them. You can see here a great view looking back down onto the final configuration of one of those blankets that covered those lines as Nick and I were outside doing the final cleanup before getting ready to head back in and start preparing for EVA-3.
Our third spacewalk focused on the cupola. Here Bob and I are removing the insulation that it launched in to expose those metal shutters over the windows. After the insulation was removed, we could unbolt the windows. Those bolts were designed to stop the windows coming open inside the shuttle's payload bay during launch. After each EVA, it's time to squeeze back into the airlock. This time, it's just Bob and I getting in without help, and we have to manage all of our bags in the airlock there. And at the end, we get to come back into space station, which is great. After a long EVA, we get our first real drink and some food in about 8 hours, and we get to scratch our noses for the first time.
Our EVA members were outside configuring the cooling lines and the data and power cables on the outside of Node 3. We had to get busy on the inside of Node 3, setting up all the environmental control and life support and crew systems. You see us here. We carried up about 750 pounds of cargo inside of Node 3, and we had to unstow that and then get busy setting up all the different systems. These systems are very important and critical to sustaining a crew of 6 people on board the International Space Station. Here you see Bob outside working away while we were working inside to set up air revitalization systems and water recovery systems. And also, we're setting up a treadmill and also a weightlifting machine, which is quite tricky in the microgravity of space. We also had to set up the inside of the cupola to get that all ready to go, and setting up all the different components to be able to provide this new capability. Here you see Stevie Ray working on some of the fluid lines on the for the waste hygiene compartment, turning yesterday's coffee into tomorrow's water. Very important for the long duration life of the International Space Station. So as you can see, Node 3 is quite busy here, but as we got all these racks moved, it was time to go ahead and have the official ribbon cutting ceremony and officially open Node 3 for business.
Endeavour shadow there on the top left. This was just spectacular. In space, it takes about a little less than 15 seconds to go from black through pink and orange to bright white, and that's a view that you never get tired of seeing. Here's a view of Endeavour backing away, and you can see how crowded it is there with all of us on the flight deck doing different tests and taking pictures. During the docking at Rendezvous, I did not have a chance to see the station. I was busy in the front cockpit, so this is my first chance to see it. And here we are flying over Mount Everest. It was just amazing. Mount Everest is the tallest mountain down there. Just a beautiful view, impossible to describe.
The robotics officer inside the space station flight control room is confirming that the integrated cargo carrier is now being lifted out of Atlantis' payload bay. The retention latches that held it down inside have been released. So the station's arm is now in control of lifting that out and flying it over to where it will shortly be installed on the mobile base structure.
Houston Station 1 for SSRMS. We show ourselves at the end of step 11.2.
We copy, Tracy. Thanks for all the great work. We'll take it from here. And as you know, if you do see the things moving outside, we will be continuing with RoboOps for the next quite a few hours.
Thanks, Rob. Thanks, Rob. Thanks for the great support, you guys.
Meanwhile, Garrett Reisman, Steve Bowen are currently inside the Quest airlock. They're wearing some oxygen masks at this point in time. This is all standard procedure for them to breathe some enriched oxygen for about 45 minutes. They will be able to close the hatch between Quest and the rest of the station coming up in about 15 minutes or so. And then once that is done, they will reduce the pressure inside Quest from 14.4, where it's at right now, down to 10.2 psi. And that is where it will stay overnight.
EVA.
Atlanta, Houston, go ahead.
Big G, you have a go to open that and stow it. And if you would, just let me know when you get it open. Correct. I'm lifting it up now. Oh, it is daylight outside.
I wouldn't lie to you.
Whoa, that's cool. Okay, the hatch is open. Okay, and you got her stowed? Just a second. Yeah, take your time. Yeah, Big G, that's the bottom of South America. That's awesome. Nice sunny day out here. Looking good. About another 20.
Okay, copy. Another 20.
Garrett Reisman, you see there, he's guiding the station's robotic arm with a you'll hear periodically a GCA. That's basically a ground controlled approach. He's guiding verbally, as he can see the arm much better than Piers Sellers can, so he is going to be guiding it over closer to him so that he can climb into that foot restraint that he installed on the end of the arm.
Brakes on.
All right, I got clearance to the dish. Tony, I think I'm headed to ingress, right?
Yeah, yep, all the way into ingress.
Okay, copy.
Steve Bowen now holding the new space-to-ground antenna boom. He'll hold on to that while Garrett Reisman climbs into the foot restraint on the end of the station's robotic arm. After that, Bowen will hand off the boom to Garrett Reisman.
Okay, Piers, you ready?
Ready. And we're going to take you zenith first.
Please, I can see the UHF antenna. We're well clear of it.
Okay, and the dish?
The dish we are well clear. No issues with the dish. Any settings? 0. I got 12. Yeah, 0 golf.
Garrett Reisman is in position on the end of the station's robotic arm, holding the spare boom for the space-to-ground antenna to be installed on the Z1 truss you see there in the upper center of the picture.
For a translation to the airlock toolbox.
All right.
Continuing.
Stop motion.
Stop motion.
Garrett Reisman with the space-to-ground antenna dish firmly in hand, being maneuvered now back over to the installation point. This view from the perspective of Steve Bowen, the nose of Space Shuttle Atlantis,
CWC eyes.
taking photos of his colleague Garrett Reisman off in the distance on the end of the station's robotic arm with the spare space-to-ground antenna dish being relocated to the Z1 truss element of the station, where it will be permanently housed as a redundant and secondary antenna.
On the OSPPB.
Hey, and Tony, just let you know, we just got KU back. If they're working here, when they get done and they get a moment, if they can have somebody just kind of show us the interface while they kind of give it that little push and tug, just so to see what's going on, that'd be great.
Okay, you can see in Garrett's view there, he was seeing the largest gap, and you can see that interface right there. You can tell there's not much of anything there.
You ready for you guys, if you're watching, I'll wiggle it.
We're watching, Garrett.
Ready? Whoa. Oh, you got a huge shot. Yeah.
We did see that. Thanks. That helps.
I think we need to retorque them.
Wow. No problem. So hold off on the heat shield. They should let us go to a higher torque after seeing that.
Yeah. I didn't think it was on good. We still got a problem with this connector, though.
All right, guys, I'll ask you this first, and then give you a chance to speak up before we talk to Houston, but at some point we're just staring at this connector and not making much progress. How about you, Big G? Got any words before we hit the ground?
It is a big advantage to having the two of us here to try to work together. I'd say we give one more big effort to get it on. And how long till sunrise?
Just another minute. So if you want to cover up the
yeah, I got it covered up.
Yeah, that's going to keep that cold and keep it small?
Yeah. Right.
Okay, we just got KU back.
I think I got it. I think it's on my side. I think that's your side. Still off a bit. Off a bit. There it is. Yep, that's up it. Hey, it's on. Ta-da! Woohoo!
Okay, Swanee, what do you want for WBS?
All right.
Hey, good work, everybody. Thank you. That's a good job waiting for the sun, too. Good plan.
Thanks, buddy. All right, you ready for the interface rocking?
Garrett Reisman and Steve Bowen have now split their attention to two different tasks. Garrett Reisman will go work on the installation of this work site for the Dexter robot. Steve Bowen is still working on this spare space-to-ground antenna assembly. He's going to be removing what are called gimbal locks. These are basically just locks that are put into place to hold everything securely during Atlantis' launch, which of course brought up this piece of equipment.
Yes.
While Reisman and Bowen are working on this spacewalk, the robotics officer here inside Mission Control has confirmed that the shuttle's robotic arm has successfully grappled to MRM-1. This is some advanced activity in preparation for lifting that module out of Atlantis' payload bay and installing it on the Russian segment of the International Space Station.
Pull over release for 40 seconds. I'll take it off. Ready? Yep. On the 40. This is just releasing the locks to it. I got barber pole over barber pole.
It looks like it released. It actually moved.
And barber pole over release. Take the switch to off. Demate. That's just this one, and I should get released.
Verify which cable of the...
I got no low hover, so go position on it. Still got no lights.
To plug into Reba, was it 1008 that I'm
16,
recharging?
there's the one that's weird.
Is it the same one that I had from previous?
Okay, and
All right, Tony, so what did you do this morning?
I got up this morning and got all cleaned up. Good shave. And we pulled MRM-1 out of the payload bay, and you probably can see that better in the monitor. And in the bottom view is our camera looking at our payload bay at MRM-1, and then our top view is the station's big arm end effector, and you can see we lined it up so they can just go in and grapple. And Big G's over in the cupola flying the big arm. He's going to grapple the module and plug it into the bottom of the space station.
And Big G on the big loop. The SRMS has MRM-1 at the handoff position with the brakes on. We go for grapple.
looks good.
This is a live action shot.
Live action.
You can't see. The angle's not too good, but this is Garrett.
Grappling MRM-1.
Grappling MRM-1.
You're at the MRM-1 clearance position with the brakes on. You go to maneuver to the MRM-1 pre-dock position.
Okay, copy all. We're going to put that in work.
And this is roughly a 20-minute maneuver that will reposition the Rassvet module at its pre-install position. The module has a number of components on the outside destined for future use at other locations on the International Space Station.
And Houston, ISS Robo. We looked like a pretty good docking. We never got contact one, straight down the middle, and got capture and contact.
The station's robotic arm is operated from inside the cupola. The view you see here is of Garrett Reisman and Piers Sellers, as they have been pretty much in charge of the station robotic arm operations throughout the day. The robotic workstation was relocated from the U.S. lab Destiny to the robotic workstation a couple of weeks ago. Michael Good will be performing his first spacewalk of this mission. This will be his third EVA, and his colleague Steve Bowen, who joined Garrett Reisman on the first spacewalk 2 days ago, he'll be wearing a suit with a red stripe.
That looks good motion.
Copy.
Good motion. A little bit further. Keep coming. Another 6 inches or so. Keep coming a little tiny bit. Perfect. Stop. You can see the impingement point where my finger is. If you guys got that in the WVS. And the impingement, the indentation went away for the most part once it was relieved, and then there's no pairing to the fabric covering.
Steve Bowen has already unsnagged the cable. He's just going to tie wrap it to the other cable that you see there. This is a view from his helmet cam 30 minutes into the EVA.
And it's turning.
Michael Good now releasing one of the two bolts securing the battery to its carrier on the P6 truss.
Completely released.
Okay, and if you've got any words for Steve-O or Garrett about running torque and indicators as you do these, just shout them out. Next will be release H2.
Yeah, running torque was nothing on H1. And you see the indicator there, Steve-O? Yep. So it went here from lock just that far on H1. It's not very far. And I could feel it, jumping on the thread at the end when I was done, kind of clicking on it. And Mike, if you could pull it to your right a little bit so I can get down the... Thank you. Tony, I really didn't feel any soft dog, man. It was just floating.
Okay, I copy. We'll be interested to see if the pallet's the same or if it's firmer.
Bowen is now handing the first new battery. He'll hand that off to Michael Good, who will head back to the work site for installation.
My red is clear. At the battery, I am going to egress the APSR. Okay. Okay, you're going to have to pitch it away a little bit. Can you push it? Yeah. Thanks. Thank you. I'll put this out. I'm going to give you that, and then you can take both and okay, I've got pitch it back. You have the battery. There we go. It's turning now. Let's see it. Battery is moving in. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, getting ready for the torque here, 16, trying to get my rate. Okay, I've got the battery. You have the battery? I'm just going to move over so you can get over to that handrail. So let me try and get in.
Michael Good now translating up to join Steve Bowen for the installation of the old battery number 3 into the empty slot B.
That is going in the hole. I think it's in the light clear this time. I'm a little bit left. Good alignment. I'm showing it. That's about as deep as I needed on H1 side.
3 brand new batteries now have been installed on the P6 truss. The crew has been given a go for the 4th battery today, so they are jumping ahead now that the new battery is installed. They are in the process now of removing the 4th old battery, battery number 4, from the P6 truss. Once they have that removed, they will install it on the pallet to be returned home aboard Atlantis, and then they will remove the 4th new battery from that pallet and install it in the empty slot.
The crew is still ahead of the timeline. Therefore, the ground team has offered up the option of taking care of this get-ahead task on this spare space-to-ground antenna. The entire objective of what they're trying to do is retighten these bolts, and they will do a wiggle or a shake test on the entire assembly to make sure it's not moving more than what is expected. If it does, they will simply try to retighten the bolts once more at a higher setting. But if it doesn't move more than what they expect, they will release the temporary tether that was put on there during the first spacewalk of the mission, and also release the launch locks that held the antenna down.
And Mike, you can do the wiggle test up at my PTP way. Okay, I'm getting down to the interface as well. And Tony, I'm doing a wiggle test. I'm not getting any motion. I'm seeing absolutely nothing. Nothing like we had the other day, that's for sure.
Okay, great.
And I don't see any gaps.
Let me give Houston a chance to weigh in here. Houston, we saw no motion at the wiggle test, and we see no gaps. We're ready to pick up in step 19.
Great job. That does it. SCAN is on firmly. We are ready for step 19 and removing gimbal locks.
Hey, Huck. What you doing, man?
Hey, where you been all day? We just had a victorious EVA. And you've been off goofing off somewhere? Come on, man. Come on.
I was holding Pierce's coffee while he was working the car.
I see. Holding the coffee. Very nice.
Somebody's got to do that, man.
Yeah, no, look out the window. This is Bueno coming into hatch.
All right, let's check it out.
After being the champion of champions.
Those guys kicked some serious butt today. Look at that. Look, he's in space, just inside this window.
I'll get him to look up.
All right, get him to look up.
Bueno, look up. Hey, come on. There he is!
There he is! The serious heroes today, both those guys. Unbelievable job.
Unbelievable.
They did.
They 4 batteries, saved the SCAN, got everybody ahead so that our next EVA is going to be awesome. We're going to get everything done.
I know. It's unbelievable.
I am so stinking happy. All right. There they are.
Yay!
The awesome smell of space.
Yeah. For those of you watching at home, you might not realize this, but space has a smell. It's actually the smell of the stuff outside the station. It kind of smells like victory.
Come on up.
Oh, there it is. There's the smell. It smells like chicken. It kind of smells like ozone or kind of electrical smell. But we call it the smell of space. Guys, unbelievable EVA. What do you have to say?
Epic.
That was fun.
It was great.
Can you do it again sometime?
Unbelievable. Hanging out there at the end of the truss, watching the world go by.
You're gonna love it, Garrett.
Unbelievable.
Really?
Yeah, gorgeous.
Was it scary?
No.
I'm a little scared.
No, don't be scared.
You sure?
Dude, it was beautiful.
Because I was looking from inside the window, and it looked really far out there.
You, who was on top of the arm.
Well,
at one time,
I know, but I kept my eyes closed the whole time.
One time we flew over South America. I could see the Amazon for as long as I could see, 1,000 miles. How long is that thing?
A long way.
I could see it forever.
Wow.
Yeah, some beautiful sunrises and sunsets too.
It's those colors you get.
Yeah,
Transitions are
beautiful.
The station's robotic arm is now being repositioned with the integrated cargo carrier, basically the giant toolbox that Michael Good and Garrett Riesman will be working off of today. They'll be installing 2 new batteries that are still remaining on this carrier onto the station, and returning 3 batteries back to this carrier. It is planned to be put back in Atlantis' payload bay on Saturday. for the return trip home.
Hey, Brandon, looks like you got about a foot between the back of the battery and the power that comes in. Okay, I can see it. Okay, cool.
Halfway, 50 to go.
Copy. That's the ingress aid.
You're looking basically through the eyes of mission specialist Michael Good as he heads back to the P6 truss to assist with the installation of the new battery. This is the 5th of 6 batteries, the first of 2 to be swapped out today and installed on the P6 truss.
I can get that once you get the battery. Okay. Okay, I have the battery. Okay, you got her. Get my local here.
Three hours, 1 minute into the spacewalk, the task of removing and replacing 6 batteries on the P6 truss has been completed. That was at 8:28 a.m. Central Daylight Time, 9:28 Eastern Time. The P6 truss now has a full complement of 6 new batteries. Those will be brought online later on in the mission.
Okay, Tony, I have the ACFR from whip 21 on my BRT with the red.
Okay, I'm going to have you go up to 5328 to get your fare lead. But if you, while you're down there, if you could just take a look around, the only thing that should be left down there that you should see is Garrett's fare lead, which should be just inboard of you. Everything else should be cleaned up.
Okay. Coming down the same way you did.
This is Garrett Reisman's camera here. As you can see, the thermal cover's open to the Quest airlock. He is inside. Mike Good just outside that hatch there. They are getting close to wrapping up today's spacewalk. Once again, this is the 3rd and final one for Atlantis' mission.
You get right there? Yeah. Getting the thermal cover? Yeah. Okay.
I just wanted to thank Mike for being the voice of ELC4 up here today and let you guys know how much we appreciate your help and that it was really very impressive working from the cupola and watching how these arms work together and getting ELC berth to the truss.
Well, Discovery is a really historic vehicle in a lot of ways. It took its name from a lot of ships of exploration over many centuries, and it comes with a pretty rich heritage, and it's really lived up to that. She just performed magnificently getting us up here, so I think we're all going to be kind of sad to see it go. And we're going to remember Discovery and all the shuttle fleet, I think, is the most capable vehicles that have ever flown in space.
So here we have B. Alvin Drew and Steve Bowen, uncharacteristically speechless. And our commander has given them all sorts of words of encouragement and also told them if they do a bad job, he won't let them back in.
Okay, heads open and stowed. Feeling good out there? Just bending and stretching, you know, you're going to wake up sometime. That coffee ought to be kicking in any time now. You see them up there with the camera?
Excellent, you guys. Let Speed finish up the whip extender task and then head back to the airlock, and then we'll be ready for...
And to the whole team there, great work completing a textbook EVA.
B. Alvin Drew, first EVA. What are you going to do now, Al?
I'm gonna have dinner like a quarter horse.
How was it?
That was awesome. Oh man, that was great. That views are outstanding.
And what are you doing today?
Well, today Mike and I are going to move the PMM, which is the big module that's currently in payload bay of Discovery, over to the station, and that will complete the assembly of the ISS.
You guys ready? Here we go. Woohoo! Yeehaw!
Nicole, I hate to ring the recess bell on you, but we only got about 15 minutes left before an extended LOS, and we have Liz here for the transfer brief before hatches close.
Wappa is off the tram and in my hands.
doing really well. They've been following instructions exceptionally well today as I boss them around.
Scott, it was a pleasure to be up here. We appreciate your hospitality. We appreciate you putting up with us, knocking your stuff off the walls, and generally trashing your station. And we're going to miss you guys. And so thanks for everything.
We're going to miss you, but most of all, we're going to miss Discovery. We wish her fair winds and following seas. Thank you.
Discovery departing. We'll miss you guys.
I've taken walks by the rolling sea, where the cliffs drop down to meet the big blue deep. I breathed in the air that rolls over these hills. I breathed it in, but I've had my fill. I gotta roll away. Maybe I'll return to this island someday. Roll away.
And Houston, this is the cupola. The UMA mate is complete, and with that, the ELC-3 is successfully installed.
Thank you very much for the great ride and safe delivery of AMS to the station.
Well, thank you, Sam. I was just looking out the window of the orbiter, and AMS looks absolutely fantastic on the truss. Well, I just wanted to say welcome back to open space, and Taz, congratulations on being the 201st human being to be in outer space. I waited a long time to say those words to you. Congratulations.
Thanks, Vic. Thank you. You know, it's a dream come true for me.
Observer Houston Freeview.
Go ahead.
We're wondering if Spanky can use, this is a quote now, gentle backhand sweeping motions to get that washer away from the Sarge.
Thank you. You'll be a Hubble EVA guy yet. Vent is open, and it is hauling out of there.
Wow.
And I'm going to keep moving away.
For the sake of the kids and the naps, the necks, and the trade-off.
Our plan is coming together.
Nice when that happens.
Yeah, we see the mounting bracket on the FGB side looks good. You guys can see that also if you're watching on WBS.
Yep, I see that.
And you're watching NASA TV.
Follow the unknown with something more familiar. Quickly, something familiar.
For the OBS standoff, use a very ultralight Ninja graceful ballerina grip, as we talked about.
EV2 is ready with Ninja ballerina grip.
In behalf of the STS-134 crew and the Expedition 27 crew, space station assembly is complete.
This space station, the pinnacle of human achievement and international cooperation. And now it's the brightest star in the sky and hopefully the doorstep to our future.